హాయ్ ఫ్రెండ్స్, వెల్కమ్ టు సైన్ టెక్నికల్ హబ్. మన ఛానల్లో అందరికీ తెలుసు ఈసెట్ ఫ్రీ ఆన్లైన్ క్లాసెస్ అయితే స్టార్ట్ చేశాం. అందులో భాగంగా సివిల్ ఇంజనీరింగ్ కి క్లాసెస్ అయితే కొన్ని సబ్జెక్ట్స్ కవర్ అయి ఉన్నాయి. స్ట్రెంగ్త్ ఆఫ్ మెటీరియల్స్ ఫుల్ సిలబస్ అయితే కంప్లీట్ చేసాం. అలాగే థియరీ ఆఫ్ స్ట్రక్చర్స్ ఫుల్ సిలబస్ కంప్లీట్ చేసాం. నెక్స్ట్ సర్వేయింగ్ పార్ట్ 1 వీడియో కంప్లీట్ అయి ఉంది. ఇప్పుడు హైడ్రాలిక్స్ పార్ట్ 1 లో క్లాస్ 1. ఇది పార్ట్ 1 సిలబస్. ఇది వాస్ట్ సిలబస్ అన్నమాట, చాలా ఎక్కువ సిలబస్ ఉంది. సో దీన్ని 2 రకాలుగా డివైడ్ చేసాము. ఫస్ట్ పార్ట్ 1. ఈ పార్ట్ 1 లో మొత్తం థియరీ ఉంటుంది. ఫస్ట్ థియరీ ఎక్స్ప్లెయిన్ చేస్తాం. ఆ తర్వాత ఇదంతా థియరీ పార్ట్. ఆ థియరీ పార్ట్ తర్వాత మనం ఓన్లీ థియరీ చదివితేనే నీకు అర్థం కాదు కాబట్టి తర్వాత మోడల్ క్వశ్చన్స్. సో ఈ మోడల్ క్వశ్చన్స్ అయితే ఎక్స్ప్లెయిన్ చేస్తాము. ఇది ఈ టాపిక్స్ వరకు రాకేష్ సార్ కి చాలా ఎక్స్పీరియన్స్ ఉంది, అలాగే చాలా గ్రిప్ ఉంది కాబట్టి రాకేష్ సార్ చేత ఈ ఈ పార్ట్ 1 అయితే చెప్పించాం. నెక్స్ట్ పార్ట్ 2. ఈ పార్ట్ 2కి వచ్చేసరికి ఇది కూడా ఫస్ట్ థియరీ క్లాస్ వస్తుంది. ఆఫ్టర్ దట్ ఆ థియరీ అయిపోయిన తర్వాత వెంటనే పార్ట్ 2 క్లాస్ 2 లో మోడల్ క్వశ్చన్స్ ఏ టైప్ లో మోడల్ లో ఉంటాయి అంటే ఈ సిలబస్ సంబంధించి ఆ మోడల్ టైప్ క్వశ్చన్ అనేది ఫ్రేమ్ చేస్తున్నాం. ఇది కార్తిక్ సారు ఆల్రెడీ ఈ టాపిక్స్ అన్ని ఒకసారి ఎక్స్ప్లెయిన్ చేస్తున్నారు. మళ్ళీ సార్ కి గ్రిప్ ఉంది కాబట్టి సో ఈ టాపిక్స్ అనేది సార్ చేపించాం. సో ఇంకా ఆలస్యం చేయకుండా మన ఫస్ట్ పార్ట్ 1 క్లాస్ 1 లోకి ఎంటర్ అయిపోదాం. మాకు వీలైనంత వరకు మేము ఫ్రీగా చెప్పడానికి ట్రై చేస్తున్నాం. ఎంకరేజ్మెంట్ చేయడానికి సబ్స్క్రైబ్ చేయండి. అలాగే షేర్ మీ ఫ్రెండ్స్ కి ఎవరికైనా ఉపయోగపడుతుంది అనుకుంటే, మీ రిలేటివ్స్ కానీ మీ ఫ్రెండ్స్ కానీ ఎవరైనా ఉంటే వాళ్ళకి షేర్ చేయండి.
మెకానిక్స్ లో డెఫినిషన్స్ అండ్ ప్రాపర్టీస్ ఆఫ్ ఫ్లూయిడ్స్ అనే టాపిక్ ని చూద్దాం. ముందుగా బేసిక్ డెఫినిషన్స్. వాట్ ఈస్ మీన్ బై ఫ్లూయిడ్ మెకానిక్స్? ఇట్స్ అ బ్రాంచ్ ఆఫ్ సైన్స్ విచ్ డీల్స్ విత్ ది బిహేవియర్ ఆఫ్ ఫ్లూయిడ్స్ at rest as well as in motion. Fluids are nothing but liquids or gases. The study of fluids at rest is called as fluid statics. The study of fluids in motion where pressure forces are not considered is called as fluid kinematics. The study of fluids in motion where pressure forces are also considered is called as fluid dynamics. The next topic is fluid properties. In that, density, it is also called as mass density. Okay, it is defined as it's a ratio of mass of fluid to its volume. It is denoted by the symbol rho. Mathematically, rho is equals to mass of fluid by volume of fluid. Mass is measured in kg, kilogram. Volume is measured in meter cube. The unit will be kg per meter cube. Okay, dimensions. How to write dimensions? Based on the unit only you write dimensions. Dimensions are write in MLT form. Here M refers to mass, L refers to length, T refers to time. Mass, unit of mass is kg. Length unit will be meter. Time unit is second. Okay. So the dimensions for mass density is written as, it is the unit kg per meter cube. Write in dimensions as m by l cube, that is equals in MLT form m l power minus 3 t power 0. Okay, I hope it is understand how to write dimensions for mass density. The value of density of water is 1 gram per cc or 1000 kg per meter cube. In numericals also, if the density of water is not given, you take 1 gram per cc or 1000 kg per meter cube. The next fluid property is specific weight. It is also called as weight density. It is the ratio of weight of fluid to its volume. It is denoted by the symbol gamma. Gamma is equals to weight of fluid by volume of fluid. There is a relationship between weight density and mass density. Weight density is equals to mass density into acceleration due to gravity. If acceleration due to gravity is not given in the problem, it is 9.81 meters per second square. SI unit for weight density is Newton per meter cube. SI unit is a derived quantity. In India, we have two system of units. One is MKS unit. Second one is CGS unit. M refers to meters, K refers to kilogram, S refers to seconds. Okay, in CGS, C refers to centimeters, G refers to grams, S refers to seconds. Hope it is understand. SI unit Newton per meter cube for the weight density. Newton in SI unit converted into MKS unit in kgf. The dimensions kgm. F has units of meter per second square, so L by T square into 1 by L cube. Okay, it gives m L power minus 2 T power minus 2. Dimensions also clear now. The value of specific weight of water is 9810. 9810. The next fluid property is specific volume. It is defined as the ratio volume of fluids to mass of a fluid. The another way of defining is volume of fluid occupied by a unit mass. Mathematically, specific volume is equals to volume of fluid by mass of fluid, that is equals to 1 by rho. Specific volume is reciprocal to mass density. Reciprocal to mass density. The unit for specific volume is, it is a reciprocal. K rho has units of kg per meter cube, so the units for specific volume is meter cube per kg. Okay, dimensions, how to write dimensions and how to derive dimensions we see for the two quantities, that is mass density and weight density. In the same manner you derive the dimensions for specific volume also. It is commonly applied for gases, not for liquids. Specific gravity, it is defined as the ratio of weight density of a fluid to weight density of a standard fluid, or it is the ratio of density of fluids to weight density of fluid. Okay, it is also called as relative density. It is denoted by the symbol S. What is standard fluid? For liquids, if you calculate a specific gravity for liquids, the standard fluid is water. If we calculate specific gravity for gases, the standard fluid is air. S is equals to, mathematical way of representation, S is equals to weight density of fluid by weight density of standard fluid. Okay, for example, I have a specific gravity of oil. I have a specific gravity of oil. I need to find mass density of oil. So what is the formula I use? S is equals to rho of oil by rho of standard fluid, that is water, I use. Okay. It has no units because weight density by weight density or mass density by mass density, same quantity is in ratio, so there is no units for specific gravity. Specific gravity of water is 1 and specific gravity of mercury is 13.6. Okay, I hope it is understand. The next property is viscosity. Viscosity. What is meant by viscosity? It is defined as the property of a fluid which offers resistance to the movement. Movement refers to the flow. Flow. That means viscosity is a fluid property which offers resistance to flow. Which offers resistance to flow of one layer of fluid over another adjacent layer of fluid. Okay. For example, it is a bed of canal. This is the particle of water. This is also a particle of water. It tries to move in this direction. The flow is in this direction. It tries to move in this direction, but some force or some resistance has to stop to move this flow of the bottom molecule of water, a bottom particle of water. This is due to viscosity. If you take the top particle in the flow, it has to move because the viscous force, the resistance to flow has to reduce when it goes to it move to upwards. Okay, I hope it is understand. The formula for this is tau is equals to mu du by dy. Okay, it is based on the Newton's law of viscosity. What it states that? It states that the shear stress is denoted by tau is directly proportional to a rate of shear strain. If you remove the proportionality, you put constant, that is mu du by dy. That proportionality constant is called as coefficient of viscosity. Okay, now it is understand. I hope it is understand. See, what is the terms? Tau is called as shear stress. Du by dy is called as rate of shear strain or rate of shear deformation or velocity gradient. It has three names: rate of shear strain, rate of shear deformation, or velocity gradient. The proportionality constant mu is there. Mu is called as coefficient of dynamic viscosity. This is I hope this is understand. The next topic is units. You see the definition of viscosity. Newton's law of viscosity also is. See the units of viscosity. Now the units of viscosity that is mu. Tau by du by dy has units of Newton per meter square. It is velocity u, that is meter per second per meter. Meter get cancelled, that is Newton second per meter square is the unit for dynamic viscosity. You know that force has unit of newtons. Okay, pressure is units of Newton per meter square. It is also called as Pascal. Okay, now this Newton second per meter square is written as Newton per meter square is written as Pascal into seconds. Okay, understand? That is the SI unit. This is derived quantity. MKS unit will be, in MKS unit Newton is written as kgf. In CGS unit it is in MKS. In CGS unit Newton is written as dyne, that is gram force. So the MKS unit will be kgf second per meter square. CGS unit will be dyne second per centimeter square. That is CGS unit for viscosity is poise. Poise is equals to dyne second per centimeter square. Okay, it has dimensions. Newton has dimensions of m l t power minus 2. I know how to write dimensions in the previous two quantities, so I directly write the dimensions for the viscosity. N has dimensions of ml t power minus 2. S has dimensions of t. M square has dimensions of L square. So the dimensions are m l t power minus 2 into t divided by L square, that is equals to m l power minus 1 t power minus 1. It is the dimensions for viscosity. Next one is note. That means you have to remember these points for your problematic or in a direct MCQs also. One poise is equals to 1 by 10 Pascal second. So 1 Pascal second is equals to 10 poise. Okay, the second point is viscosity of water at 20 degrees Celsius is 0.01 poise or 1 centipoise. Next topic is kinematic viscosity. Kinematic viscosity is defined as ratio between dynamic viscosity and density of water. Density of fluid. Dynamic viscosity by density of fluid is called as kinematic viscosity. It is denoted by the symbol nu. Mathematically, nu is equals to viscosity, that is dynamic viscosity by density of fluid. So nu is equals to mu by density, that is rho. The SI unit will be meter square per second. How it comes? Nu is equals to mu Newton, that is I write it as in SI unit kg force second per meter square divided by the kg per meter cube. Kg get cancelled, meter square meter square get cancelled. F has units of meters per second square, so 1 second get cancelled, that is meter square per second. This m goes here, that is meter square per second. I hope this understand. This is the SI unit or MKS unit. The CCS unit will be centimeter square per second, that is Stoke. 1 Stoke is equal to 10 to the power of minus 4 meters square per second. Dimensions: meters has dimensions L square, per second t power minus 1. T power minus 1. Okay. Next topic is variation of viscosity with temperature. Temperature affects the viscosity. Okay. Viscous forces in fluid are due to cohesive forces and molecular moment transfer. Okay. What is meant by cohesive force? Cohesive force refers to the force of attraction between the same particles. Water. For example, water. Sorry, for example, Hg, mercury and co. Mercury has the same molecules, has more force of attraction between cohesion. So in mercury, cohesion is more than addition. Adhesive forces refers to the force of attraction between two different, that is water and paper. Adhesive forces. And molecular moment transfer. If temperature increases, viscosity of fluids, how it changes? Okay. If temperature increases, fluids are liquids and gases. Okay. In liquids, cohesive forces are predominant. That is more. Cohesive forces more than molecular moment transfer. Whereas in gases, molecular moment transfer is more than cohesive forces. So, viscosity in liquids decreases when the temperature increases. Temperature increases, viscosity of liquids decreases. That means you write 1 by mu L, it will decrease. This is the inverse relation. That is liquids and temperature for the viscosity. Let's take for gases. For gases, both are increases. If temperature increases, viscosity increases. Temperature decreases, viscosity of gases decreases. In liquids, it is vice versa. Temperature increases, viscosity decreases. Temperature decreases, viscosity increases. This understand, I hope. The next topic is types of fluids. Ideal fluid. When a fluid is called ideal, It is incompressible and having no viscous. No viscous means frictionless. Frictionless. Okay, frictionless. No viscous. It is not exist in real life. Okay, these are imaginary fluids. Ideal fluids are real fluids. It possesses viscosity. They have viscosity. All fluids in practice are called as real fluids only. Newtonian fluids. The Newton's law of viscosity obeys a fluid obeys Newton's law of viscosity is called as Newtonian fluid. Does not obey the Newton's law of viscosity is called as non-Newtonian fluid. In other words, the same thing here also discussed. What means tau is proportional to rate of shear strain is called as Newtonian fluid. If it is not proportional, it is called as non-Newtonian fluid. Non-Newtonian fluid. If the shear stress is more than yield value, that is yield stress, yield value, shear stress is more than yield value, then it is called as ideal plastic fluid. Okay, sorry, ideal. Types of fluids. It is ideal fluid, that means no shear stress, tau is 0. Newtonian fluid, tau is directly proportional to du by dy. Non-Newtonian fluids, tau does not proportional to du by dy. The curve above Newtonian fluid and the curve below Newtonian fluid also called as non-Newtonian fluid only. The curve above Newtonian fluid is called as pseudoplastic. The curve below Newtonian fluid is called as dilatancy. Okay. If tau value is greater than yield value, then it's called as ideal plastic fluid. Types of fluid is over. The next topic is compressibility and bulk density. Bulk density is defined as the ratio of compressive stress to volumetric strain. Volumetric strain is change in volume by original volume. Compressive, that is, it is a block. This is force applied. The stress due to that compressive load is called as compressive stress. It is the ratio of compressive stress to the volumetric strain. It is denoted by letter K. I given an example for this. For the formula, take initially it is closed. The position of this is here 1. The place of 1 is changed to place 2. Then the volume will decreases. So the volume will decreases. Pressure in this case is increases. Pressure in this case is increases. Pressure in this case is increases. A volume will decreases. So the negative sign refers to the pressure increases with volume decrease, or volume decreases with increase of pressure. The unit of bulk modulus is Newton per meter square. In dimensions, Newton ml t power minus 2 divided by L square, that is Dimensions are m, l power minus 1, t power minus 2 is the dimensions for bulk density. Compressibility, it is compressibility beta, for example compressibility beta unte it is a reciprocal of bulk density. The units are also reversing, so the SI unit will be meter square per Newton. The dimensions are m power minus 1, l t power minus 2. The next topic is surface tension. It is defined as the tensile force acting on the surface of liquid in contact with gas. If it is a liquid surface, it contact with air, or the liquid surface is contact with another liquid surface. In both cases 1 and 2, a thin membrane is forming. This is due to surface tension. Best example for surface tension is mosquitoes on water surface. This is mosquito. Let's say this is mosquito. This is water surface. It cannot immerse in water. It is stand on water surface. This is due to surface tension. It is denoted by the letter sigma. The unit will be kgf per meter. This is mk's unit. In SI unit, Newton per meter. The dimensions for Newton ml, t power minus 2 divided by l get cancelled, m l power 0, t power minus 2 is the dimensions for surface tension. And surface tension on liquid droplet. P refers to pressure intensity inside the droplet. Sigma is surface tension. D is the diameter of the droplet. P is equals to 4 sigma by D. How it get? Pressure force equating pressure force with force due to surface tension. Okay. Please remember these formulas for your problematic, for numericals to solve. Surface tension on a hollow bubble like soap bubble. Both in outside also it is contact with the air, and the inside also it is contact with the air. What the surface tension definition says: water or air contact between water and air are two immiscible liquids. Contact, there is a thin layer forming due to tension. Okay, so it is two times of surface tension due to droplet. Okay, surface tension on a liquid jet is P is equal to 2 delta by D. It is like bar. This is L, this is D. The next topic is capillarity. Capillarity is defined as the phenomenon of rise or fall of a liquid surface in a small tube relative to the adjacent general level of liquid when the tube is held vertically in the liquid. This is, for example, in this liquid is present. Capillary tube I insert in vertical. If the water rises in the capillary tube, it is called as capillary rise. If the water is held in vertical in the tank, the water is the fluid in the capillary tube is falling, it is called as capillary depression or capillary fall. It is expressed in terms of centimeter or millimeter of liquid. Dimensions are L only, so m naught L to power 0. Expression for capillary rise or fall. The same formula, H is equals to 4 sigma cos theta by rho GD. Rho gamma is equals to rho G. So in place rho G you put gamma, 4 sigma cos theta by gamma D. In capillary rise condition, theta will be approximately 0. So the cos theta will be 1. So the capillary rise formula is equals to H is equals to 4 sigma rho GD, that is 4 sigma by gamma D. The value for theta for mercury and glass is 120 degrees, approximately 130 degrees. Approximately 130 degrees. Summary. Fluid in the capillary tube is water. Water tends to capillary rise. The theta value will be approximately 0. Water more addition. Okay, where in case of mercury, Hg, mercury in capillary tube, more cohesion, the theta will be 130 degrees or theta will be approximately 130 degrees. Capillary depression or capillary fall. Capillary fall. The next topic is vapor pressure. Consider a liquid which confined in a closed vessel. Take this is a vessel. Let's say this is vessel closed. It is closed. Water is present in this closed vessel. This closed vessel. This closed vessel. The temperature initially the temperature is 20 degrees Celsius and the pressure is atmospheric pressure. it is heating up, the liquid will vaporize at 100 degrees Celsius. At 100 degrees Celsius, vaporization takes place, molecules escape from the free surface of the liquid. It is closed, these are vaporized and accumulated at the free surface. These vapor molecules get accumulated in the space between the free liquid surface. This is a free liquid surface and the top of the vessel. This is the top of the vessel. These accumulated vapors exert a pressure on the liquid surface. These vapors exert a pressure on this liquid. This pressure is called as vapor pressure of that liquid. That pressure is called pressure at which liquids is converted into vapors, is called as vapor pressure. I hope this understand clear. It's clear. The next topic is cavitation. Consider a flowing liquid in a system. If the pressure at any point in this flowing liquid becomes equal to or less than, you consider less than or equals to, may be equal, might be equal, but it is less than vapor pressure. Okay, the vaporization of the liquid starts. For example, I take a river. Here the pressure is less than or equals to vapor pressure. Okay, vapor pressure. The bubbles of these vapors are carried by the flowing liquid into the region of high pressure where they collapse, giving rise to high impact pressure. The pressure developed by the collapsing bubbles is so high that the material from the adjoining boundaries gets eroded and cavities are formed on them. This phenomenon is known as cavitation. ఈ విధంగా ఉన్నప్పుడు బబుల్స్ అనేటివి ఫామ్ అవుతాయి, వేపర్ బబుల్స్. అవి హై ప్రెషర్ రీజన్స్కి వెళ్ళినప్పుడు కొలాప్స్ అయిపోతాయి. ఆ కొలాప్స్ అవ్వడం వల్ల ఏం అవుతుందంటే అక్కడుండే ఫర్ ఎగ్జాంపుల్ సాయిల్ అనుకుంటే ఆ సాయిల్ అనేది ఎరోడ్ అయిపోతుంది. అక్కడ పిట్స్ లాగా తయారవుతుంది అనమాట. ఆ పిట్స్ తయారవుతున్నాయి కదా, అవి వాటిని క్యావిటీస్ అంటారు. ద ప్రాసెస్ని ఏమంటారంటే క్యావిటేషన్ అంటారు. ఈ టాపిక్ మనకు స్టాటిక్స్ కిందకు వస్తుంది, ఎందుకంటే ఈ టాపిక్లో మనము ఫ్లూయిడ్ని రెస్ట్ కండిషన్లో ఉంచి అనాలిసిస్ చేస్తాం. ఏపీపీఎస్సికి సంబంధించి ఫ్లూయిడ్ ప్రెషర్ అండ్ ఇట్స్ మెజర్మెంట్స్లో ఉన్న టాపిక్స్ ఏంటంటే అట్మాస్ఫియరిక్ ప్రెషర్, గేజ్ ప్రెషర్, అబ్సల్యూట్ ప్రెషర్, పీజోమీటర్, మానోమీటర్, యూట్యూబ్ మానోమీటర్, ఇన్వర్టెడ్ యూట్యూబ్ మానోమీటర్, డిఫరెన్షియల్ మానోమీటర్. ఫస్ట్, వాట్ ఈజ్ మెంట్ బై ఫ్లూయిడ్ ప్రెషర్? ఫ్లూయిడ్ ప్రెషర్ అంటే ఏంటి? అట్ ఎ పాయింట్, ఏదైనా పాయింట్ దగ్గర ఫ్లూయిడ్ ప్రెషర్ని ఏ విధంగా డిఫైన్ చేస్తాం? ఫర్ ఎగ్జాంపుల్, ఇట్స్ ఎ బాడీ, ఐ అప్లై ఫోర్స్ ఆన్ ఇట్, a force is uniformly distributed over the area and the pressure at that point is force by area. The force is called as pressure force, and force is written as P into A. A force has units of newtons and the pressure has units of Newton per meter square. Why? Because A is measured in meter square, F is measured in newtons. These are some units. The pressure measured in SI unit is Newton per meter square, in MKS unit is kgf per meter square, in CGS unit is dyne per centimeter square. Newton is written as kg meter per second square as per the Newton's second law of motion. F is equals to ma. The unit of Newton is equivalent to kg meter per second square. The dimensions are derived from the Newton is kg meter per second square. So ml t power minus 2. The pressure has Newton per meter square. So ml t power minus 2 divided by L square, that is ml power minus 1 t power minus 2 is the dimensions of pressure. Next is Pascal's law. Pascal's law states that pressure at a point in a static fluid, that means the fluid is at rest condition, is equal in all directions. That means in x direction, in y direction, in z direction, the pressure is equal. The pressure is equal. Px is equals to py is equals to pz. That is the Pascal's law. The next one is hydrostatic law. The pressure at any point in a fluid at rest is obtained by the hydrostatic law. At any point, you measure a pressure by hydrostatic law. It states that rate of increase of pressure is equals to the specific weight of that fluid. The rate of increase of pressure in a vertically downward direction must be equal to the specific weight of the fluid at that point. dP by dz is equals to gamma. Gamma is equals to rho g. If you integrate this, dP will be p and dz will be z, that is equals to rho g. P by z is equals to rho g. Z is equals to P by rho g. This z is called as pressure head. Pressure head. The next topic is absolute gauge, atmospheric and vacuum pressure. How these are defined? We have two systems. In one system, absolute zero or completely vacuum pressure is taken as a datum. In another system, atmospheric pressure is taken as datum. Absolute pressure. In this pressure, we take absolute vacuum pressure as reference and calculate the pressure called as అబ్సల్యూట్ ప్రెషర్. మనము అబ్సల్యూట్ వాక్యూమ్ ప్రెషర్ని రెఫరెన్స్ తీసుకొని ప్రెషర్ని కాడ మెజర్ చేస్తే దాన్ని అబ్సల్యూట్ ప్రెషర్ అంటాం. గేజ్ ప్రెషర్ అంటే ఏంటంటామంటే అట్మాస్ఫియరిక్ ప్రెషర్ని మనం డేటమ్ చేసుకొని ప్రెషర్ని కాడ మెజర్ చేస్తే దాన్ని గేజ్ ప్రెషర్ అంటాం. వాక్యూమ్ ప్రెషర్ ఏంటంటామంటే అట్మాస్ఫియరిక్ ప్రెషర్ కంటే బిలో అంటే కింద ఉంటే అట్మాస్ఫియరిక్ ప్రెషర్ కంటే బిలో ఉన్నట్లయితే దాన్ని వాక్యూమ్ ప్రెషర్ అంటాం. ఈ వాక్యూమ్ ప్రెషర్ని ఏమంటామంటే మనము నెగిటివ్ గేజ్ అని అంటాం, నెగిటివ్ గేజ్ ప్రెషర్ అని కూడా అంటాం. అదేవిధంగా సక్షన్ ప్రెషర్ అని కూడా అంటాం. దీన్ని వాక్యూమ్ ప్రెషర్ని సక్షన్ ప్రెషర్ అంటాము, నెగిటివ్ గేజ్ ప్రెషర్ అని కూడా అంటాం. The next one is some relations are drawn between absolute to gauge atmospheric pressures. This is absolute zero line. This is atmospheric pressure. This is the point above the atmospheric pressure. Absolute zero నుంచి మనం మెజర్ చేస్తే దాన్ని ఏమంటాము అబ్సల్యూట్ ప్రెషర్ అంటాం. సో పి అబ్సల్యూట్ ఈజ్ ఈక్వల్స్ టు అబ్సల్యూట్ ప్రెషర్ దేనికంటే ఎక్కువ ఉంది అట్మాస్ఫియరిక్. సో అట్మాస్ఫియరిక్ ప్రెషర్ కంటే ఎక్కువ ఉంది ప్లస్ అట్మాస్ఫియరిక్ ప్రెషర్ ప్లస్ గేజ్ ప్రెషర్. దాన్ని ఏమంటామంటే అబ్సల్యూట్ ప్రెషర్. దిస్ ఈజ్ ఫస్ట్ రిలేషన్. ద సెకండ్ రిలేషన్ వచ్చేసి ఏంటంటే అట్మాస్ఫియరిక్ ప్రెషర్ కంటే తక్కువ ఉంటే దాన్ని ఏమంటాం వ్యాక్యూమ్ ప్రెషర్ అంటాం. సో a point considered in between absolute zero pressure line and the atmospheric pressure line. ఆ టోటల్ వచ్చేసి ఏంది, టోటల్ సమ్మేషన్ వచ్చి అట్మాస్ఫియరిక్ ప్రెషర్. సో పి అట్మాస్ఫియరిక్ ఈజ్ ఈక్వల్స్ టు పి అబ్సల్యూట్ ప్లస్ పి vacuum. I need vacuum, so P vacuum is equals to P atmospheric minus P absolute. This is the second relation between the pressures. Some important points to remember are, first point is atmospheric pressure at sea level at 15 degrees centigrade is 101.3 kilonewton per meter square, 10.13 newton per centimeter square, or 1.033 kgf per centimeter square. Okay, generally the value 1 atmospheric is equals to 1 atm. What an atmospheric pressure is equals to 101325 Pascal, that is Newton per meter square. This Pascal converted into kilonewton per meter square, and it is converted into Newton per centimeter square, and it is converted into kgf per centimeter square. Okay, this is the first point. And second point is atmospheric pressure head in terms of mercury is 760 mm, in terms of water is 10.33 meters. The next one is measurement of pressure. Measurement of pressure. ఈ ప్రెషర్ని రెండు డివైజులతో మెయిన్గా మెజర్ చేస్తాం. ఒకటి వచ్చి మానోమీటర్స్, ఇంకోటి వచ్చి మెకానికల్ గేజెస్. మెకానికల్ గేజెస్ అనేవి మనకు సిలబస్లో లేవు కాబట్టి వాటిని స్కిప్ చేద్దాం. మానోమీటర్స్ ఉన్నాయి కాబట్టి వాటిని డీటెయిల్గా చూద్దాం. మానోమీటర్స్ డెఫినేషన్ ఏంటంటే, అవి ఎందుకు అంటే యూజ్ అవుతాయంటే ప్రెషర్ని కనుక్కునేదానికి. ఓకే, మానోమీటర్స్ ఆర్ డిఫైన్డ్ యాజ్ ద డివైజెస్ used for measuring pressure at a point in a fluid by balancing the column of a fluid by the same or another column of the fluid. మానోమీటర్స్ మళ్ళీ క్లాసిఫై చేశారు. అవి ఏంటంటే సింపుల్ మానోమీటర్స్ అండ్ డిఫరెన్షియల్ మానోమీటర్స్. ఇన్ సింపుల్ మానోమీటర్స్ యూ ఫైండ్ ప్రెషర్. ఇన్ డిఫరెన్షియల్ మానోమీటర్స్ యూ ఫైండ్ difference in pressure. Difference in pressure. Simple manometers. Simple manometers consists of a glass tube. One end is connected to a point where pressure is to be measured. I need to measure pressure in this point. So I connect this a glass tube to that point, and the remaining is open to atmosphere. Okay, this is a simple diagram for that. ఇందులో మళ్ళీ టైప్స్ ఉన్నాయి. ఏంటంటే పీజోమీటర్ అని, యూట్యూబ్ మానోమీటర్ అండ్ సింగిల్ కాలమ్ మానోమీటర్. సింగిల్ కాలమ్ మానోమీటర్ ఈజ్ నాట్ ఇన్ అవర్ సిలబస్, but piezometer and YouTube manometer are in our syllabus. Piezometer, this figure represents piezometer. Okay, it is a simple form of manometer measuring gauge pressures. Remember this point. It is used to measure gauge pressures. One end of this manometer is connected to a point where pressure is to be measured. ఇక్కడ నేను పాయింట్ కనుక్కోవాలనుకున్నాను ప్రెషర్. అక్కడికి ఒక ఎండ్ని నేను కనెక్ట్ చేశాను గ్లాస్ ట్యూబ్తో, ఇంకొక ఎండ్ని ఏం చేశాను, ఇంకొక ఎండ్ని ఓపెన్ టు అట్మాస్ఫియర్కి పెట్టేశాను. ద రేస్ ఆఫ్ లిక్విడ్ గివ్స్ ది ప్రెషర్ హెడ్. ఇది లిక్విడ్ హెడ్ ఇక్కడ వరకు ఉంది. ఈ హెడ్ ఏంటంటే మనకు ప్రెషర్ హెడ్ అనమాట. ఈ హైట్ వచ్చేసి మనకు ప్రెషర్ హెడ్. అది నేను ఇప్పుడు ఈ పాయింట్లో ఇక్కడ నేను ప్రెషర్ కనుక్కోవాలనుకున్నప్పుడు ఈ ప్రెషర్ హెడ్ ఇంటూ rho into g, which is based on hydrostatic law. Z is equals to P by rho g. So P is equals to rho g z. ఇక్కడ z వచ్చేసి h కాబట్టి the formula becomes rho g into h. The next one is YouTube manometer. It consists of glass tube bent in U shape. ఈ విధంగా ఉంటుంది. One end of which is connected to a point at which pressure is to be measured. నేను ఎక్కడైతే ప్రెషర్ కనుక్కోవాలనుకుంటున్నానో అది ఒక ఎండ్కి కనెక్ట్ చేస్తాం, ఇంకొక ఎండ్ వచ్చేసి ఓపెన్ టు అట్మాస్ఫియర్ పెడతాం అన్నమాట. దీంట్లో 2 ఫ్లూయిడ్స్ ఉంటాయి. ఒకటి వచ్చి మానోమెట్రిక్ ఫ్లూయిడ్, ఒకటి వచ్చి ఫ్లోయింగ్ ఫ్లూయిడ్. దీని డెన్సిటీ అనేది హైగా ఉంటుంది. ఫ్లోయింగ్ ఫ్లూయిడ్ డెన్సిటీ వచ్చేసి లో ఉంటుంది ఇన్ యూట్యూబ్ మానోమీటర్. ఇన్ దిస్ లో density, flowing fluid density is low and manometric fluid density is high. Here we find gauge pressures as well as vacuum pressures. That means this is atmosphere pressure. Based on this reference as datum, atmospheric pressure as a datum, I use it to measure vacuum, P vacuum, as well as in upward direction it is called as P gauge. These figures represent, the first one is for the gauge pressure, the second one is for the vacuum pressure. Actually the flowing fluid at this point, that means the water or anything or oil are in this position, it is for the manometric fluid. For this is flowing fluid. This is I taken as this AAS datum. How to measure pressure in YouTube manometer? First I tell you, మనం ముందుగా గేజ్ ప్రెషర్కి ఈక్వేషన్ ఏ విధంగా ఫైండ్ చేయాలో చూద్దాం. H1 is height of flowing fluid, H2 is height of manometric fluid based on the datum line. నేను ఇక్కడ ప్రెషర్ కనుక్కోవాలనుకుంటున్నాను P. సో ఫస్ట్ నేనేం చేస్తానంటే లెఫ్ట్ సైడ్ అండ్ రైట్ సైడ్, ఫస్ట్ నేను లెఫ్ట్ సైడ్ కనుక్కుంటాను. ఇక్కడ P ఉంది కదా, P ప్లస్ H1 హైట్ ఉంది. సో ρ1, దిస్ డెన్సిటీ ఈజ్ ρ1 అనుకుంటే G ఇంటూ H1 లెఫ్ట్ సైడ్ ప్రెషర్. రైట్ సైడ్ డెన్సిటీ వచ్చేసి ρ2 G ఇంటూ H2. ఈ రెండింటిని ఈక్వేట్ చేస్తే మనకు Pకి ఈక్వేషన్ వస్తుంది. ఏం చేస్తున్నానంటే నేను ρ2 G H2. సో P ఈజ్ ఈక్వల్స్ టు ρ2 G H2 మైనస్ ρ1 G H1. సింపుల్. ఓకే. I hope this is understand for everyone. And next, how to find pressure for vacuum pressure. వాక్యూమ్ ప్రెషర్ కేస్ దీనికి ఏ విధంగా కనుక్కోవాలో చూద్దాం. వాక్యూమ్ ప్రెషర్ కేసులో ఫ్లోయింగ్ ఫ్లూయిడ్ అనేది హైట్ అనేది తక్కువ ఉంటుంది. ఓకే, ఇన్ దిస్ కేస్ flowing fluid height is more. Consider AA line as datum. Here atmospheric pressure 0, so P ఇక్కడ 0, right side 0, left side P ఇక్కడ P ఉంటుంది అనుకుంటే P plus ఇక్కడ H1 for the height of flowing fluid, rho 1 GH1 plus this is rho 2 GH2. This left side equating to right side is 0, so P is equals to minus of rho 1 GH1 rho 2 GH2. This is the equation for vacuum pressure in the case of YouTube manometer. The next one is single column manometer. This is not in our syllabus, but how they look like, that's why I put in the slide. Is the modification for the YouTube manometers. In this case, two types of single column manometers: vertical single column manometer and inclined single column manometer. This is vertical single column manometer, it is inclined single column manometer. The next one is differential manometer. Differential manometer. Differential manometers are the devices used for the measuring the difference of pressures between 2 points or in 2 different points. Here we find out difference of pressure. We find out the difference of the pressure. A differential manometer consists of U-tube containing a heavy liquid whose two ends are connected to the point whose difference of pressure to be measured. ఓకే, ఇందులో టూ టైప్స్ ఉన్నాయి. ఒకటి వచ్చి యూట్యూబ్ డిఫరెన్షియల్ మానోమీటర్, అనదర్ వన్ ఈస్ ఇన్వర్టెడ్ యూట్యూబ్ డిఫరెన్షియల్ మానోమీటర్. ఇంతకుముందు మనం యూట్యూబ్ మానోమీటర్ని ఏ విధంగా చూసాం? దిస్ ఈస్ యూట్యూబ్ మానోమీటర్. ఓకే, బట్ ఇన్ differential manometer it is connected to another point. That means here A point, here B point. That is called as U-tube. Inverted U-tube means it is inverted. Look like this. YouTube differential manometer. It has two cases. First one is A and B are at different levels and contains different liquids. Also contains liquid of different specific gravity. In differential manometers, what you have to find? Difference in the pressures. Pressure A minus pressure B. How this equation came, I tell you. First I take left hand limb. That means this part, this is the reference. I take this part. Here pressure at A is PA minus PA. This is the height, x plus h plus rho 1 g x plus rho 1 g h. This is left hand side. The right hand side will be pb plus rho 2 g y plus rho g, that is heavy fluid, has a specific has a density of rho g, into g into h. Equating these two, pa minus pb is equals to, in this term gh is common, so rho g minus rho 1 into g into h plus rho 2 gy minus rho 1 gx is the equation. You can see this equation. Here pa minus pb is equals to rho g minus rho 1 times of g into h plus rho 2 into g into y minus rho 1 into g into x. The next case is 2 points A and B at the same level and contains the same liquid, that is density is same, the difference in pressure. This is the second case. This is the second case diagram. Take this is as reference. So PA plus A plus x plus h, right? So rho 1 gx plus rho 1 gh. This is left hand limb, and the right hand limb is pb plus rho 1 gx plus rho g gh. Equating these two terms are cancelled, and pa minus pb is equals to rho g minus rho 1 into g into h. This is the equation we got. The next is inverted U-tube differential manometer. It consists of an inverted U-tube, that is inverted U-tube containing a light liquid. Light liquid means the manometric fluid is lighter than flowing fluid. Okay, the two ends of the tube are connected to a point whose difference of pressure is to be measured. It is used for measuring difference of low pressure. Difference of low pressure ని కనుక్కునే దానికి మనము ఇన్వర్టెడ్ U-tube ని యూస్ చేస్తాం. దిస్ ఈజ్ ద ఈక్వేషన్ we get while solving. This is the figure. This is PA, this is PB. In this case we measure PA, this is plus, but in inverted you take PA minus. This is H1, this is taken as datum, so this rho 1 G H1. This is left hand side pressure, left side. This is left side. In the right side is PP minus rho 2 GH2 minus This is S, right? So rho S G H. GH. PA minus PB will be rho 1 GH1 minus rho 2 GH2 minus rho SGH. This is the equation. I hope this class will help you. In the next class we see hydrostatic forces on plane surfaces and bus ఏంటంటే pressure on plane surface immersed in liquid, in that horizontal plane surface immersed in liquid, vertical plane surface immersed in liquid, inclined plane surface immersed in liquid. Immersed means submerged. For example, this is the surface of liquid, this is body, this is liquid. This body is called as సబ్మర్జ్డ్ బాడీ. అంటే మొత్తం మునిగిపోయింటే బాడీ అనేది దాని సబ్మర్జ్డ్ బాడీ అంటాం. ఓకేనా? లేకపోతే దిస్ ఈజ్ బాడీ, ద సర్ఫేస్ ఆఫ్ వాటర్ ఈజ్ దిస్ ఈజ్ కాల్డ్ పార్షియల్లీ సబ్మర్జ్డ్ బాడీ అని అంటాం దాన్ని. ఓకే, ఈ బాడీని ఏమంటామంటే పార్షియల్లీ సబ్మర్జ్డ్ అంటాం. ఈ బాడీని సబ్మర్జ్డ్ ఆర్ ఫుల్లీ సబ్మర్జ్డ్ బాడీ అని అంటాం. ఓకేనా? ముందుగా మనము టోటల్ ప్రెషర్ అంటే ఏంటి, సెంటర్ ఆఫ్ ప్రెషర్ అంటే ఏంటో చూద్దాం. ఇట్ ఈస్ డిఫైన్డ్ యాజ్, టోటల్ ప్రెషర్ ఈజ్ డిఫైన్డ్ యాజ్ ఫోర్స్. ఇట్స్ ఎ ఫోర్స్, ఇట్స్ నాట్ ప్రెషర్. టోటల్ ప్రెషర్ ఈజ్ ఎ ఫోర్స్ exerted by a static fluid, that means the fluid is in rest condition on a surface, either plane or curved, when the fluid comes in contact with the surfaces. This is the surface of liquid, this is liquid, this is liquid. A vertically submerged body, I take vertical plane surface, I take submerged in liquid. Okay, the water comes in contact with the surface, a force is exerted on the surface. That force acts normal to the surface. This is the surface, the force acts normal to the surface. This is pressure force, acts normal to the surface. The point of application of the total pressure force on the surface is called center of pressure. Next one is vertical plane surface submerged in liquid. Actually we don't need any derivations. మనకు డెరివేషన్స్ ఏం అవసరం లేదు, జస్ట్ ఫార్ములా తెలిస్తే చాలు. ఇంకేనా? నేను ఈ వర్టికల్ ప్లేన్ సర్ఫేస్కి మాత్రమే డెరివేషన్ ఏ విధంగా చేయాలో చెప్తాను. ద రిమైనింగ్ 2 కేసెస్, దట్ ఈజ్ హారిజంటల్ ప్లేన్ సర్ఫేస్ అండ్ ఇన్క్లైన్ ప్లేన్ సర్ఫేస్కి జస్ట్ ఐ గేవ్ ఫార్ములాస్. ఓకే, A is the total area of the surface, G is the center of gravity, P is the center of pressure, H bar is the distance of center of gravity of the area from the free surface of the liquid. H bar అనేది ఫ్రీ సర్ఫేస్ ఆఫ్ ద లిక్విడ్ నుంచి సెంటర్ ఆఫ్ గ్రావిటీ వరకు ఉండే డిస్టెన్స్ని హెచ్ బార్ అంటాం. ఫ్రీ సర్ఫేస్ ఆఫ్ ద లిక్విడ్ నుంచి సెంటర్ ఆఫ్ ప్రెషర్ వరకు ఉండే డిస్టెన్స్ని హెచ్ స్టార్ అంటాం. ఓకే, టోటల్ ప్రెషర్ ఫోర్స్, దిస్ ఈజ్ ఫోర్స్. టోటల్ ప్రెషర్ ఫోర్స్ని ఫర్ వర్టికల్ ప్లేన్ సర్ఫేస్ సబ్మర్జ్డ్ ఇన్ లిక్విడ్ కేస్కి ఏ విధంగా కనుక్కుంటామో చూద్దాం. దిస్ ఈజ్ ద సర్ఫేస్ ఆఫ్ ద ఫ్రీ సర్ఫేస్ ఆఫ్ ద లిక్విడ్. ఇట్ ఈస్ vertical plane surface submerged in liquid. Consider a strip on the vertical plane surface whose width is b and depth is dh. The area of the strip is b into dh. The pressure is rho gh, because h is the distance from free surface of liquid to the strip. Okay, h from the hydrostatic law, P is equals to rho gh. I need pressure force on the strip, so df is equals to P into dA. For the strip, this is for strip, I need total surface, so I integrate this, I get F is equals to rho g a h bar is the pressure force for whole surface. Okay, vertically plane surface submerged in liquid, the total pressure force will be F is equals to rho g a h bar. Next one is center of pressure. H star అనేది మనకు ఫ్రీ సర్ఫేస్ నుంచి సెంటర్ ఆఫ్ ప్రెషర్ వరకు ఉండే డిస్టెన్స్ హెచ్ స్టార్. దీన్ని ఏ విధంగా క్యాలిక్యులేట్ చేస్తామంటే బై యూజింగ్ ప్రిన్సిపల్ ఆఫ్ మొమెంట్స్, ఇట్ స్టేట్స్ దట్ మొమెంట్ ఆఫ్ రిజల్టెంట్ ఫోర్స్ అబౌట్ అన్ యాక్సిస్ ఈజ్ ఈక్వల్ టు ద సమ్ ఆఫ్ మొమెంట్స్ ఆఫ్ ద కాంపోనెంట్స్ అబౌట్ ద సేమ్ యాక్సిస్. ఇక్కడ రిజల్టెంట్ ఫోర్స్ ఏంటి, స్ట్రిప్ నుంచి మనం హోల్ కనుక్కున్నాం, సో ఎఫ్ ఈజ్ రిజల్టెంట్. ద మొమెంట్ caused due to this pressure force is called moment of the resultant force. So moment due to resultant force will be F into H star for this strip, dF into H. I integrate all sum, I get rho g I naught. From this, H star is equals to rho g I naught divided by F. F is nothing but rho g a H star. Rho g get cancelled, so H star is equals to I naught by a H star, H bar, sorry. From parallel axis theorem, I naught is equals to Ig plus a H bar. Okay. So substitute I naught in this equation, we get H star is equals to Ig by a H bar plus H bar. This is the equation for center of pressure distance. This is the equation. The next one is, some points to be remembered are, center of pressure lies below the center of gravity of the vertical surface. Okay, this is center of gravity, center of pressure. Okay, H star is equals to Ig by a H bar plus H bar. This is H star is H bar plus, this is free surface, this is H bar, this is plus Ig by AH, this distance. Okay, so Cp is below the Cg, center of pressure is below the Cg. First point is clear. The next one is the distance of center of pressure, that is H star. Free surface of the liquid is independent of density of the liquid. The equation is Ig by a H bar plus H bar. In this term, we don't have rho, so it is independent of density, but the pressure force is rho g a H star, so F is, it is dependent of density of the liquid. The next one is, give some important plane surfaces, rectangle, triangle, circle, trapezoid, they give for the mi. that means moment of inertia. First rectangle CG from the base is d by 2, area is BD, moment of inertia about center of gravity centroid is BD cube by 12, from the base is BD cube by 3. For triangle CG from the base is x is equal to h by 3 and the area is half into BH, and the moment of inertia will be BH cube by 36, about the base is BH cube by 12. Next, the plane surface is circle. It has CG from the base is d by 2 and the area is pi by 4 d square, and the moment of inertia about the centroid is pi d power 4 by 64. For the trapezium, x is equals to 2a plus b by a plus b into h by 3. A is top width, b is bottom width of the trapezium. This is centroidal distance from the base. Area is a plus b by 2 into h, and the moment of inertia is a square plus 4ab plus b square by 36a plus b into h cube is the moment of inertia about centroid. The next one is horizontal plane surface submerged in liquid. Here the total pressure force is also same. F is equals to rho GA H bar is the pressure force. It won't H star is equals to H bar in this case. Why? Because it is in horizontal plane. The H star and H bar are lies in the same plane, so the distance is same. The next one is inclined plane surface submerged in liquid. In this case, total pressure is total pressure force F is equals to rho G A H bar. Inclined surface, it is inclined with theta degrees, so H bar is equals to y bar sin theta. Remember this, F is equals to rho G A H bar. The center of pressure is H star is equals to Ig sin square theta by a h bar plus h bar. The formula is sufficient to remember the formula, that is sufficient to solve the problems in this unit. Where A is the total area, H is equals to this is H. In this figure we can observe that this is H. From the free surface to center of gravity of the inclined surface, H star is free surface to center of pressure of the inclined surface. Okay, theta is angle made by the plane of the surface with liquid. This is the surface, this is angle theta subtended by theta. The y dash is distance from the center of inclined surface from O. This is reference they take in inclined plane. I hope this class is helpful. ఫ్లో ఆఫ్ ఫ్లూయిడ్స్ అనే టాపిక్ని చూద్దాం. ఎవరన్నా మా ప్రీవియస్ వీడియోస్ చూడనట్లయితే డిస్క్రిప్షన్లో లింక్ ఉంటుంది, వెళ్ళి చూసేయండి. ఫ్లో ఆఫ్ ఫ్లూయిడ్స్ని ఏ విధంగా డిఫైన్ చేస్తామంటే, ద స్టడీ ఆఫ్ ఫ్లూయిడ్స్ ఇన్ మోషన్. ఇట్ ఈస్ క్లాసిఫైడ్ ఇంటూ 2 parts. The first one is fluid kinematics and the second one is fluid dynamics. In fluid kinematics, we did not consider the pressure forces. In fluid dynamics, we consider the pressure forces. Okay. ఈరోజు క్లాస్లో మనం ఫ్లూయిడ్ కైనమాటిక్స్ సంబంధించి చూద్దాం. ఏపీపీఎస్సికి సంబంధించి ఫ్లూయిడ్ కైనమాటిక్స్కి సిలబస్ ఏంటంటే టైప్ ఆఫ్ ఫ్లో. ఇన్ దట్ యూనిఫామ్ అండ్ నాన్ యూనిఫామ్ ఫ్లో, streamline and turbulent flow, steady and unsteady flow. It is under fluid kinematics. First we know what is meant by fluid kinematics. It is defined as branch of science which deals with the motion of particles without considering the forces causing the motion. In simple words, it is the study of fluid in motion without considering the ప్రెషర్ ఫోర్సెస్. ఫ్లూయిడ్ మోషన్ని డిస్క్రైబ్ చేసేదానికి మనకి మెథడ్స్ ఉన్నాయి. అవి ఏంటంటే మెయిన్లీ 2 మెథడ్స్లో మనం ఫ్లూయిడ్ మోషన్ని డిస్క్రైబ్ చేస్తాం. ఫస్ట్ వన్ ఈజ్ లాగ్రేంజియన్ మెథడ్ అండ్ సెకండ్ వన్ ఈజ్ యూలేరియన్ మెథడ్. లాగ్రేంజియన్ మెథడ్లో మనము సింగిల్ ఫ్లూయిడ్ పార్టికల్ని కన్సిడర్ చేసి డ్యూరింగ్ ఇట్స్ మోషన్ ఆ సింగిల్ పార్టికల్ని మనం దాని మోషన్ పీరియడ్ అంతా దాన్నే ఫాలో అయ్యి వెలాసిటీ, యాక్సిలరేషన్ అండ్ డెన్సిటీని మనం డిస్క్రైబ్ చేస్తాం. దాన్ని లాగ్రేంజియన్ మెథడ్ అంటాం. ఇంకొక మెథడ్ ఏంటి? యూలేరియన్ మెథడ్. ఇన్ దిస్ కేస్ ఆల్సో we describe velocity, acceleration, pressure and density described at a point in the flow field. అక్కడ ఒక పార్టికల్ని లాగ్రేంజియన్ మెథడ్లో ఒక ఫ్లూయిడ్ పార్టికల్ని తీసుకొని త్రూఅవుట్ ఇట్స్ మోషన్ పీరియడ్లో మనం దాని వెలాసిటీ, యాక్సిలరేషన్, డెన్సిటీ అనేటివి డిస్క్రైబ్ చేస్తాం. ఇన్ యూలేరియన్ మెథడ్లో ఏం చేస్తామంటే ఒక పాయింట్ ఫ్లో ఫీల్డ్లో ఒక పాయింట్ కన్సిడర్ చేసి ఆ పాయింట్కి సంబంధించి వెలాసిటీ, యాక్సిలరేషన్, ప్రెషర్, డెన్సిటీ అనేటివి మనం డిస్క్రైబ్ చేస్తాం. ఫర్ అవర్ బెటర్ అండర్స్టాండింగ్ we can see Lagrangian method and Eulerian method in pictorial form. Let's say this is flow field. Let's say this is flow field. Flow field. I consider a single fluid particle here and I follow during its motion period, and I follow this particle in its motion period, and I describe velocity, acceleration, density for this particle. That method is called as Lagrangian method. Let's say I consider a point in the flow field. This is a point I consider. In that point, I describe velocity, acceleration, pressure, density. That is called as Eulerian method. I hope it is clear. Next, fluid flow ni ఏ విధంగా క్లాసిఫై చేశారంటే స్టడీ అండ్ అన్స్టడీ ఫ్లోస్, యూనిఫామ్ అండ్ నాన్ యూనిఫామ్ ఫ్లోస్, laminar and turbulent flows, compressible and incompressible flows, rotational and irrotational flows, 1, 2 and 3 dimensional flows. In our syllabus, first 3 flows, that is steady and unsteady, uniform and non-uniform, laminar and turbulent flow in our syllabus. This is not in our syllabus. This is not in our syllabus. Compressible, incompressible, rotational, irrotational, 1, 2 and 3 dimensional flows are not in our syllabus. But we see compressible and incompressible, rotational and irrotational flows along with above 3, that is steady, unsteady, uniform and non-uniform, laminar and turbulent. Why? Because మనం డైనమిక్స్కి వెళ్తే మనకు కంప్రెసిబుల్, ఇన్కంప్రెసిబుల్ ఫ్లోస్ అనేటివి ఆ టర్మ్స్ అనేటివి వస్తున్నాయి అన్నమాట. వాటిని అండర్స్టాండింగ్ చేసుకోవాలంటే ఇక్కడ మనం వీటిని నేర్చుకోవాలి. అంటే ఆ ఫ్లోస్ అంటే ఏంటో ముందు తెలుసుకుంటే మనకు అక్కడ ఈజీగా అర్థమవుతుంది. ఫస్ట్, స్టడీ ఫ్లో. ఇట్ ఈస్ డిఫైన్డ్ యాజ్ దట్ టైప్ ఆఫ్ ఫ్లో ఇన్ విచ్ ద ఫ్లూయిడ్ క్యారెక్టరిస్టిక్స్, దట్ ఈస్ velocity, pressure, density, etc. at a point. That means we represent here the Eulerian form, Eulerian method. Okay, do not change with time. With respect to time, the fluid characteristic do not alter, do not change. So in mathematically, velocity dou v by dou t, with respect to time, the velocity is cannot alter, that is do not change. So this is for velocity with respect to time at a point x0 y0 z0 is equals to 0. It represents the fluid characteristic of velocity do not change with respect to time at a point it refers to, and the pressure with respect to time at a point x0 y0 z0 is equals to 0. It refers to did not change, and the density also. And unsteady flow, it is the type of flow in which the velocity, pressure or the density at point changes with respect to time. టైంతో పాటు ఫ్లూయిడ్ క్యారెక్టరిస్టిక్స్ వెలాసిటీ, ప్రెషర్, డెన్సిటీ అనేటివి చేంజ్ అవుతాయి. దేంట్లో? అన్స్టడీ ఫ్లోలో velocity with respect to time at a point x0 y0 z0 is not equal to 0. It refers to the velocity with respect to time is changing, and the pressure also dou p by dou t at a point x0 y0 z0 is not equals to 0. That means the pressure with respect to time at a point x0 y0 z0 is changing, and the density also. I hope it is clear. And the next one is uniform flow. It is defined as the type of flow in which the velocity at any given time, so here at any given time means the time is constant, does not change with respect to space. That space refers to length of direction of flow. Let's say this is the flow, this is the direction of flow. We consider the length direction. This is the direction, this is the length direction we consider. In that direction the velocity did not change, that means did not alter. That is called as uniform flow. In non-uniform flow, the velocity at a given time changed with respect to space. I hope it is also clear. The next type is laminar flow. It is defined as type of flow in which the fluid particles move along well-defined paths or streamline. All streamlines are straight, that means all streamlines are straight enough, straight, and those are all parallel to each other. Thus particles move in laminas. Laminar flow, how it gets means the particle move in laminas. Laminas means layers gliding smoothly over the adjacent layer. ఒకదాని మీద ఒకటి స్మూత్గా మూవ్ అవుతుంటాయి అన్నమాట, కాబట్టి దానికి లామినార్ ఫ్లో అని నేమ్ వచ్చింది. దిస్ ఈజ్ ఆల్సో కాల్డ్ యాజ్ లామినార్ ఫ్లో ఈజ్ ఆల్సో కాల్డ్ యాజ్ స్ట్రీమ్లైన్ ఫ్లో ఆర్ విస్కస్ ఫ్లో. ఇట్ ఈజ్ ఆల్సో కాల్డ్ యాజ్ స్ట్రీమ్లైన్ ఫ్లో ఆర్ విస్కస్ ఫ్లో అని కూడా అంటాం. The next one is turbulent flow. It is defined as a type of flow in which the fluid particles move zigzag. That means they did not follow a straight line. అవి స్ట్రైట్గా వెళ్ళవు, దే ఫాలోస్ అ జిగ్జాగ్ వే, వంకర టింకరగా వెళ్తాయి అన్నమాట. దే డిస్పర్స్ లైక్ దిస్, ద ఫ్లో లైక్ దిస్. దే డిడ్ నాట్ ఫాలో దిస్. ఈ విధంగా పావు ఈ విధంగా వెళ్తాయి, వాటికి ఇష్టం వచ్చిన విధంగా అవి మూవ్ అవుతాయి. సో ద పార్టికల్స్ మూవ్ ఇన్ జిగ్జాగ్ వే, సో దట్ ఇట్ నేమ్ యాజ్ turbulent flow. Due to movement of fluid particles in a zigzag way, the eddy formation takes place. Eddies means, let's say this is a movement of flow. Some water is getting reversed and form some circle currents. Reverse currents are formed. This is called eddies. Due to eddies, energy loss will takes place. High energy loss will takes place. This eddy formation is also called as reverse current formation. Okay, it is clear, I hope. Next, based on a non-dimensional number. We classify the laminar flow and the turbulent flow. That non-dimensional number is called as Reynolds number. Reynolds number RE is equals to rho Vd by mu. Vd by nu Re in simple way. Okay, d is the diameter of pipe, v is the mean velocity of the pipe, and the kinematic viscosity is nu. What is meant by mean velocity? I clear this doubt. This laminar flow is considered for mostly in pipe flows. This is pipe. This is pipe. The flow, the velocity, this is the flow. The velocity at the middle of the pipe is more when compared to the edges. Why? Because here some resistance will be there, some viscosity will be there. So the velocity when compared to the edges of the pipe, the maximum is more. So we consider the mean is equals to v at middle of the pipe plus at the edges divided by 2. This is the mean velocity. We consider mean velocity in Reynolds number. If the Reynolds number is less than 2000, it is called as laminar flow. It is greater than 4000, it is called as turbulent flow. It is between 2000 to 4000, it is called as transitional flow. Or whether it is laminar or turbulent, it is a transition in between laminar and turbulent, so it is called as transitional flow. The next one is, here our syllabus is over. It is the extra part. We know compressible flow and incompressible flow for the dynamics part. డైనమిక్స్ లో ఈ టెర్మినాలజీ వస్తుంది కాబట్టి అవి అర్థం కావాలి కాబట్టి మనం ఇక్కడ ఈ డెఫినేషన్స్ని కూడా చూద్దాం. కంప్రెసిబుల్ ఫ్లో అంటే ఏంటి? ఇట్ ఈస్ ద టైప్ ఆఫ్ ఫ్లో in which the density of the fluid changes from point to point. Density is changing. Density is not constant. Density is changing. That is called as compressible flow. If the density is constant, that is called as incompressible flow. Liquids like water, oil, petrol, kerosene are comes under incompressible flows. And the gases like oxygen, carbon dioxide, nitrogen, etc. are comes under compressible flows. Okay. The next one is rotational flow and irrotational flow. Rotational flow is nothing but the type of flow in which the fluid particles flowing along streamline. That means well defined lines. They follow the laminar flow. They flow the like streamlines, and the fluid particles rotate about their own axis. It is called rotational flow. It is not rotate about its own axis, that is called as irrotational flow. Okay, they follow the fluids are flowing along streamline. That means they are like laminar flow. In that the fluid particles rotate about their own axis, it is called as rotational flow. Do not rotate about its own axis, that is called as irrotational flow. I hope this class is useful for you. If you like the class, please share to your friends. Fluids part 2, that is fluid dynamics అనే టాపిక్ని చూద్దాం. ఎవరైనా మా ప్రీవియస్ వీడియోస్ చూడనట్లయితే లింక్ డిస్క్రిప్షన్లో ఉంది, వెళ్ళి చూసేయండి. ఏపీపీఎస్సి ఎగ్జామ్కి సంబంధించి ఫ్లూయిడ్ డైనమిక్స్ క్రింద ఉన్న సిలబస్ ఏంటంటే energies in fluid motion in that datum head, pressure head and velocity head, total energy of a fluid in motion, that is Bernoulli's theorem, practical applications of Bernoulli's theorem in that pitot tube, venturi meter and orifice meter. First, what is meant by fluid dynamics? It is the study of fluid motion with the forces causing flow. In another way of defining is, it is the study of fluid in motion considering the pressure forces. The dynamic behavior of a fluid flow is analyzed by Newton's second law of motion, that is F is equals to ma, which relates the acceleration with the forces. The fluid is assumed to be incompressible and inviscous. Incompressible means the density is constant. And the non-viscous means the viscosity is zero, that means frictionless. Next, the total energy of a fluid in motion, that is Bernoulli's theorem. The statement of Bernoulli's theorem is, it states that in a steady ideal flow of an incompressible fluid, the total energy at any point of the fluid is constant. The total energy at any point is constant. The total energy consists of pressure head, kinetic head and potential head or datum head. First, we see what is meant by steady ideal flow. Steady flow means the flow characteristics such as velocity, pressure and density with respect to time at any point are not changing. In mathematically, we write dou v by dou t at a point x, y, z equals to 0. This is called steady flow. Ideal flow refers to viscosity is 0, that is frictionless. Incompressible fluid means the density is constant. Statement of Bernoulli's theorem చూసాం. ఇప్పుడు అజంప్షన్స్. బెర్నౌల్లీస్ ఈక్వేషన్ డిరైవ్ చేసేటప్పుడు సమ్ అజంప్షన్స్ అనేటివి చేయడం జరిగింది. అవి ఒక 4 ఉన్నాయి. దాంట్లో మొదటిది వచ్చి ద ఫ్లూయిడ్ ఈజ్ ఐడియల్, దట్ ఈస్ viscosity is 0. It refers to frictionless. The flow is steady, that is the flow characteristics, that is velocity, pressure, density etc. with respect to time at any point doesn't change. Incompressible, the flow is incompressible, that means the density is constant. The flow is irrotational, that means the fluid particle does not rotate about its own axis. It follows the streamlines. The flow is in streamlines only, but it does not rotate about its own axis. That is called irrotational flow. These are the 4 assumptions made in Bernoulli's theorem or Bernoulli's equation. Next, Bernoulli's theorem, how we can derive this from the Euler's equation of motion. We can derive the Bernoulli's equation from Euler's equation. The Euler's equation is dp by rho plus g dz plus v dv is equals to 0. This is the Bernoulli's equation. If you need a detailed derivation of Euler's equation, please refer Archibald textbook. Otherwise, in the last we provide material. Please refer it also. If you understand Euler's equation of motion detailedly. And Bernoulli's equation is obtained from the Euler's law is by integrating the Euler's equation. By integrating dp by rho, we get p by rho plus g dz gz plus v dv, that is v square by 2. ఓకే, నేను సింప్లిఫై చేయడం కోసం నేనేం చేశానంటే జీని అన్నిటితో డివైడ్ చేశాను. సో పీ బై రో జీ ప్లస్ జెడ్ ప్లస్ వి స్క్వయర్ బై 2g. దిస్ ఈజ్ ది ఫార్ములా ఫర్ Bernoulli's equation. This is the equation of Bernoulli's equation. That is p by rho g plus z plus v square by 2g is equals to constant is the Bernoulli's equation. P by rho g plus z is called as piezometric head. It is called as piezometric head. Next, energies in fluid motion. Bernoulli's equation of motion is given by, from the last slide we see p by rho g plus z plus v square by 2z is equals to constant. This is the Bernoulli's equation of motion. P by rho g is called as pressure energy per unit weight of the fluid or pressure head. Z is called as potential energy per unit weight or potential head or datum head. V square by 2g is called as kinetic energy per unit weight or kinetic head or velocity head. These are all energies only. Okay, so the Bernoulli's equation is based on the conservation of energy. The point is noted is it is based on the conservation of energy. ఏది బెర్నౌల్లీస్ ఈక్వేషన్ అనేది కన్జర్వేషన్ ఆఫ్ ఎనర్జీ మీద బేస్ అయి ఉంటుంది. వాట్ ఇట్ సేస్, కన్జర్వేషన్ ఆఫ్ ఎనర్జీ సేస్ energy neither be created nor be destroyed. Energy neither be created nor be destroyed. This is the conservation of energy. Next one is Bernoulli's equation for real fluid. The Bernoulli's equation was derived on the assumption that fluid is inviscous, that is non-viscous. Frictional less అనుకొని మనం Bernoulli's equation చేసాం. But in real fluids the viscosity is present, right? Viscosity is present for the real fluids and hence they offer resistance to flow. There are some losses in fluid flow, hence in the application of Bernoulli's equation these all losses have to taken into consideration. Okay, for the real fluids the Bernoulli's equation for 2 points is changing like this. For the first point, p1 by rho g plus v1 square by 2g plus z1 is the at the first point. This is, let's say this is a flow. I consider this is first one point, this is second point. For the first point the total energy is p1 by rho g plus v1 square by 2g plus z1. And the second point p2 by rho g plus v1 square by 2g plus z2. HL for the real fluid, it is the loss of energy between the point 1 to point 2, loss of head. Next one is practical applications of Bernoulli's equation. The Bernoulli's equation is applied in all problems of incompressible fluid flow. If the flow is incompressible, the Bernoulli's equation is applicable. There are 3 measuring devices, namely Venturi meter, orifice meter, petard tube are the practical applications of Bernoulli's equation. These are based on the Bernoulli's equation. They work based on the Bernoulli's equation. Okay, venturi meter and orifice meter are used to measure the rate of flow, that is discharge, and in the pitot tube is used to measure the velocity. Next one is the venturi meter. Venturi meter is a device used for measuring the rate of flow, that is the density, sorry, the rate of flow, that is discharge. It consists of three parts: a short converging part, throat, and diverging part. This is converging part, this is diverging part, this is throat. This is called as inlet, this is called as outlet, this is called as throat. It is based on the principle of Bernoulli's equation. The next one is venturi meter. We don't need any derivations, but we need only the formula for the problems. We remember this formula. Based on the Bernoulli's theorem only, these rate of flow equations are derived. If you have any doubt, please refer RK Bansal textbook. Rate of flow through venturi meter. This is the venturi meter. Q is equals to A1 A2 by square root of A1 square minus A2 square into under root 2GH. It is the rate of flow. This is a theoretical one. If you calculate actual, you multiply the theoretical rate of flow with the coefficient of discharge. Coefficient of discharge. If you calculate the real fluids, we calculate head loss, right? The head loss is equals to, for the venturi meter, 1 minus CD square into H. This is the formula for head loss for venturi meter. The coefficient of venturi meter, its value is less than 1. It is less than 1. The next, the value of H. This is the H value, right? For determining H value, we have 4 ways. By using differential U-tube manometer. Let the differential manometer contain the liquid which is heavier than the flowing liquid. That is, manometric fluid is heavier than the flowing liquid. Then the H value is determined. H is equals to X into specific gravity of heavier fluid by specific gravity of flowing fluid minus 1. This is the formula to determine the H value in case of the manometric fluid is more than the flowing fluid, the density. Okay, SH is a specific gravity of heavier liquid, S0 is specific gravity of the flowing liquid, H is the difference of heavier liquid column in U-tube. Okay, the next case is if the differential manometer contains the liquid which is lighter than the liquid flowing through the pipe. That is, the manometric fluid, the density of the manometric fluid is less than the flowing fluid. Then the formula of H is given by H is equals to X into 1 minus SL minus S0. SL refers to, this is called the specific gravity of manometric fluid, that is lighter liquid. S0 is flowing fluid. If the venturi meter, the first two cases for horizontal venturi meter, that is, the venturi meter is, this is the venturi meter. Let's say this is the venturi meter in the first two cases. That is, this is a throat, this is a converging, it is a diverging part, horizontal one for the first two cases. If the venturi meter is inclined, what is the formula? Inclined, what is the formula? sorry, the figure is not up to scale. This is a rough sketch only for your understanding. This is inclined one. How the h value is determined? By using the specific gravities and by using the pressure head and by using the heads also. This is the first point, this is the second point. Okay, inclined. So at the first point we calculate datum head and the pressure head, minus in the second point you calculate the h value. This is the first method. In the second case we calculate the heavier liquid case also, x into sh by s naught minus 1. This is the another formula to calculate h value in the inclined venturimeter. If the manometric fluid, the density of manometric fluid is heavier than the flowing fluid. In the next case, the manometric fluid is less than the flowing fluid in case of inclined venturimeter. Okay, based on the heads also we can find, and based on the specific gravities also we can find the h value. This is the formula: p1 by rho g plus z1 minus p2 by rho g plus z2, that is equals to, this is x into 1 minus sl by s naught. This is the specific gravity of manometric fluid, that is lighter. S naught is flowing fluid. I hope up to this point clear. The next one is orifice meter or orifice plate. It is also used to measure the rate of flow, that is discharge only, Q value only, of a fluid through a pipe. It is cheaper device as compared to the venturimeter. Why? Because venturimeter, it is pipe. This is one, it's one, this is throat, and this is a diverging pipe. This is the heavy arrangement of venturimeter, more arrangement. But in case of orifice meter, just we put an orifice plate, that is, this is a pipe flow, this is a pipe flow. I put orifice plate here, I put orifice plate here. That means it is, the flow is like converged from here. It is just a plate, it's not a heavy arrangement, so it is very cheaper than venturimeter. It also works on the same principle. It's also same principle of Bernoulli's theorem only. Same principle. It consists of flat circular plate which has a circular sharp edged hole called orifice, which is concentric with the pipe. That is, concentric means inside పైప్కి లోపల ఉంటుంది అని చెప్పేదాన్ని కాన్సెంట్రిక్ అనేది అని చెప్తాం. The orifice diameter kept generally 0.5 times diameter of the pipe, generally varies 0.4 to 0.8 times of the pipe diameter. Generally it is varies a dia of orifice, right? DO is equals to 0.4 to 0.8 times of a diameter of the pipe. Generally we adopt 0.5 times of diameter of the pipe. This is orifice meter. Let's say this is the figure of orifice meter. This is the figure of orifice meter. This is the direction of the flow. This is the orifice meter. If you measure h value You put differential manometer. The discharge equation will be Q is equals to A naught Cc under root 2gh. Why? Because here the flow is contracted, so we consider coefficient of contraction Cc value. What is meant by Cc? We can study in the next chapter, next topic. This is the general formula, but Cc is not known for me. We get a relationship of CD and CC and put the CC value in the above equation. We get Q as CD into A naught A1 under root 2gh by under root A1 square by A naught square. This is the discharge equation for orifice meter. CD is coefficient of discharge for orifice meter. The coefficient of discharge for orifice meter is much smaller than that of Venturi meter. Venturi meter is less than 1. The discharge coefficient CD value for the orifice meter is very less than the Venturi meter. The next one is petard tube. It is mainly used for measuring velocity of the flow at any point. It is based on the principle that if the velocity of the flow at a point becomes 0, at a point the velocity of the flow is 0, the pressure there is increased due to conversion of kinetic energy into pressure energy. Okay, this is the principle behind the petard tube. In its simple form, the petard tube consists of glass tube bent at 90 right angles, that is 90 degrees with the horizontal. The theoretical velocity will be root 2gh. The actual velocity will be Cv into root 2gh. Cv value is coefficient of petard tube. Actually, the Cv is coefficient of velocity. Okay, we don't need any derivations. Just we remember the formula to solve the problems. That's enough. If you need, please text me. I make a document on the derivations also. The next one is petard tube. Velocity of flow in a pipe by petard tube. It have 4 cases to find the velocity at any point in a pipe by using petard tube. The first case is petard tube along with vertical piezometer. This is the first case. Petard tube, a vertical piezometer. This is the first case. The second one is petard tube connected with piezometer tube. This is petard tube connected with piezometer tube. And finally, we determine the velocity. We find the velocity of the flow. The third case is petard tube and vertical piezometer tube connected with a differential U-tube manometer. This is the third case. This is a petard tube U-tube manometer. You can connect this. For the U-tube manometer, you calculate the H value. And the third case is a petard static tube which consists of 2 circular concentric tubes, one inside the another. This is one and this is another, with some annual space in between. The outlet of these 2 tubes are connected to a differential manometer. This tube and this tube is connected to a differential manometer, where the difference of pressure head is H is measured by knowing the difference of the levels of the manometer liquid, say X. We use the same formula for determining H value. I hope this class is helpful for you. Please like the session. If you like the session, please share to your friend. Orifices and mouth pieces అనే టాపిక్ చూద్దాం. మనం ఈరోజు క్లాస్లో డిస్కస్ చేసుకునే టాపిక్స్ ఏంటంటే డెఫినేషన్ ఆఫ్ ఆరిఫైస్, టైప్స్ ఆఫ్ ఆరిఫైసెస్, వీనా కాంట్రాక్టా, కోఎఫిషియంట్ ఆఫ్ వెలాసిటీ, కోఎఫిషియంట్ ఆఫ్ కాంట్రాక్షన్, కోఎఫిషియంట్ ఆఫ్ డిశ్చార్జ్, సబ్మర్జ్డ్ అండ్ పార్షియల్లీ సబ్మర్జ్డ్ ఆరిఫైసెస్, ఫ్లో త్రూ ఆరిఫైసెస్. ఎవరైనా మా ప్రీవియస్ వీడియోస్ చూడనట్లయితే లింక్ డిస్క్రిప్షన్లో ఉంది, వెళ్ళి చూడండి. ఫస్ట్ What is the definition of orifice? Orifice is a small opening of any cross section such as circular, triangular, it may be rectangular or square, etc. on the side or at the bottom of a tank through which a fluid is flowing. ఆరిఫైస్ అంటే ఏం లేదు, ఒక ట్యాంక్కి మనం స్మాల్ ఓపెనింగ్ అని ప్రొవైడ్ చేస్తే ఆ ఓపెనింగ్ అనేది ఆ ట్యాంక్ ఒక సైడ్ కానీ లేకపోతే బాటంలో కానీ ప్రొవైడ్ చేయాలి. ఆ ప్రొవైడ్ చేసిన ఆ ఓపెనింగ్ అనేది సర్క్యులర్ షేప్ కానీ రెక్టాంగులర్, ట్రయాంగులర్, స్క్వేర్ షేప్లో కానీ ఉంటుంది. అది ఎందుకంటే మనం అది ఎందుకు ప్రొవైడ్ చేస్తామంటే ఫ్లూయిడ్ అనేది ఫ్లో అయ్యేదానికి మనం దాన్ని ప్రొవైడ్ చేస్తాం. సో ఆ ఓపెనింగ్ ఏమంటామంటే మనము ఆరిఫైస్ అంటాం. ఎందుకు ఆరిఫైసెస్ని యూస్ చేస్తామంటే ఆరిఫైసెస్ ఆర్ యూస్డ్ ఫర్ ద మెజర్మెంట్ ఆఫ్ ద రేట్ ఆఫ్ ఫ్లో. దట్ మీన్స్ ఇట్ ఈస్ యూజ్డ్ టు మెజర్ ద డిశ్చార్జ్ ఆఫ్ ఫ్లో. ఓకే, నెక్స్ట్ క్లాసిఫికేషన్ ఆఫ్ ఆరిఫైసెస్. మనం ఆరిఫైసెస్ని క్లాసిఫై చేయాలంటే సమ్ పారామీటర్స్ని బేస్ చేసుకొని మనం క్లాసిఫికేషన్ అనేది చేయడం జరుగుతుంది. ఆ పారామీటర్స్ ఏంటంటే సైజు, షేపు, నేచర్ ఆఫ్ ద డిశ్చార్జ్ అండ్ షేప్ ఆఫ్ ద అప్స్ట్రీమ్ ఎడ్జ్. ఈ 4 పారామీటర్స్ని బేస్ చేసుకొని మనం ఆరిఫైసెస్ అన్నిటిని క్లాసిఫై చేస్తాం. బేస్డ్ ఆన్ ద సైజ్ ఆఫ్ ద ఆరిఫైస్ అండ్ ద హెడ్ ఆఫ్ ద లిక్విడ్ ఫ్రమ్ ద సెంటర్ ఆఫ్ ద ఆరిఫైస్. ఇది బేస్ చేసుకొని మనం ఆరిఫైస్ని స్మాల్ ఆరిఫైస్ అండ్ లార్జ్ ఆరిఫైస్ అని క్లాసిఫై చేసాం. సైజ్ ఆఫ్ ద ఆరిఫైస్, వీ నో వాట్ ఈజ్ మెంట్ బై సైజ్. సైజ్ మీన్స్ ఇట్స్ డయామీటర్, లెట్స్ సే diameter of the orifice or dimensions of the orifice. Okay, what is meant the head of the liquid, we know. Okay, first we draw a sketch of a tank with orifice. This is tank, placed orifice at the side of the tank. So this is the center of the orifice. This is the surface of liquid in the tank. The distance between center of orifice to the surface of liquid in the tank is called the head of the liquid. It is denoted the letter capital H. Okay, based on the H and the dimensions, let's say the depth of the orifice, it is denoted by D naught. Depth is denoted by D naught. Based on the H and the size of the orifice, we classify the orifices as 2 types, small orifice and large orifice. ఎప్పుడు మనం స్మాల్ ఆరిఫైస్ అనాలి, ఎప్పుడు మనం లార్జ్ ఆరిఫైస్ అని అనాలి చూద్దాం. ఇఫ్ ద హెడ్ ఆఫ్ liquid is greater than 5 times of depth of orifice, it is called as small orifice. If H is less than 5 times of depth of the orifice, it is called as large orifice. The next classification is based on the cross sectional area. It refers to the shape of the orifice. If the orifice is in circular, it is called as circular orifice. If it is triangle in shape, it is called as triangular orifice. If it is in rectangular in shape, it is called as a rectangular orifice. If it is in square, it is called as square orifice. Okay, the next classification is based on the shape of upstream edge of the orifices. It is classified as sharp edged orifice and the bell mouthed orifice. The next classification is based on the nature of the discharge. Free discharging orifice, another one is drowned or submerged orifice. This drowned or submerged orifice is again classified into 2 types, that is fully submerged and partially submerged orifices. Let's see what is the difference between sharp edged orifice and the bell mouthed orifice. I draw a rough sketch, we can understand easily. For our better understanding, I draw a sharp edged orifice and a bell mouthed orifice. This is a tank. The tank have some thickness. Okay, the edge is like this, a sharpness, it is called as sharp edged orifice. If the orifice is like the bell mouth, let's see, this is the bell mouth, right? Like this, it is called as bell mouthed orifice. I hope the classification is clear. Next, vena contracta. Consider a tank fitted with a circular orifice in one of its sides. Let's say this is the tank and a fixed a circular orifice at its one side. And H is the head of water. The liquid flowing through the orifice forms a jet of liquid whose area of cross section is less than the area of the orifice. Let's say this is a orifice. Okay, this is a jet. The diameter of the jet is less than the diameter of the orifice. That means area of the jet is less than the area of the orifice. If the area of the jet flows goes on decreasing and decreasing, and at a section CC the area is minimum. Okay, at this section the area will be minimum. If you write a continuity equation, Q is equals to AV, okay, A is inversely proportional to the velocity. A is minimum, so the velocity will be maximum. Okay, at the vena contracta, the area will be minimum, the velocity will be maximum. Remember this point. Next, this section is approximately at a distance of half of diameter of the orifice. Let's see. This is section CC. From the orifice to section CC, the distance is d0 by 2, diameter of the orifice by 2, that is half of the diameter of the orifice. It is approximate distance, not exact one, it is approximate distance. The next, in that section the streamlines are straight enough and parallel to each other and perpendicular to the plane of the orifice. This is the plane. Let's say this is the plane of the orifice. These are the lines parallel to each other. Okay, they are like streamlines. They are perpendicular to the plane of the orifice. That section is called the vena contracta. This section CC is called vena contracta. Beyond this section, the jet diverges and is attracted by downward direction by the gravity. From this section, after this section, the jet is falling down due to the gravity action. For this, the theoretical velocity will be 2gh. Okay, the actual velocity is equals to some constant into theoretical velocity. That's why the actual velocity is always less than the theoretical velocity, because the CV, the constant, we put the constant, it is CV is called the coefficient of velocity, it is less than 1, so that the actual velocity is always less than the theoretical velocity. I hope it is clear. Next we move for the hydraulic coefficients. Coefficient of velocity, coefficient of contraction, coefficient of discharge, combinedly called as hydraulic coefficients. Okay, first we see coefficient of velocity. What is meant by coefficient of velocity? Coefficient of velocity is the ratio of actual velocity by theoretical velocity. Actual velocity represented v by theoretical velocity, the formula is 2gh. This is based on formula. If I conducted an experiment in the laboratory, if this is the tank, and this is the orifice. The jet is like this. I consider a point here. From this orifice to this, it is x, and from this the point is located in y direction. Then the CV is given by x by under root of 4yh. H is the head. From this is the h value, head of the liquid. So x by under root of 4yh is also formula for the coefficient of velocity. Generally, the coefficient of velocity for different orifices, it is varies from 0.95 to 0.99 based on the size, shape and head of the liquid. Okay, based on the shape, size and head, the CV value is varies 0.95 to 0.99. Generally, for sharp edged orifice, CV is given as 0.98. Okay, in venturimeter we study the head loss HL is equals to 1 minus CD square times of H. This is the formula for the in venturimeter. Here in terms of CD, this is the formula. In terms of CV, that is coefficient of velocity, the HL formula is written as 1 minus CV square into H. This is the formula. This is derived from the Bernoulli's equation for real fluids. బెర్నౌలీస్ ఈక్వేషన్ నుంచి ఈ ఫార్ములాని హెచ్ఎల్, దట్ ఈజ్ హెడ్ లాస్ అనే ఫార్ములాని మనం డెరైవ్ చేసుకుంటాం. ఫర్ ది రియల్ ఫ్లూయిడ్స్ ఓన్లీ ద head of loss is present in the formula, so that we derive HL for real fluids only. The next one is coefficient of contraction. It is the ratio of area of jet at vena contracta to the area of the orifice. It is denoted by the letter CV. The value is varies from 0.61 to 0.69 depending on the shape, size and head of the liquid. Generally, the CC value is taken as 0.64. The next hydraulic coefficient is coefficient of discharge. This is the ratio of actual discharge by theoretical discharge. Okay, if the continuity equation is applicable, A into V actual by A of orifice, this is at jet into theoretical. If we write as this is as CC into velocity, actual velocity by theoretical velocity, you can write as CV. So CD is equals to CC into CV. It is the relation between CC, CD, CV. Generally, the CD value is varies from 0.61 to 0.65. General purpose we take 0.62 as CD value. The next concept is flow through large orifices. When you call the orifice is large, head of the liquid is less than 5 times of the depth of the orifice, then it is called as large orifice. In case of small orifice, the velocity in the entire cross section of the jet is considered to be constant. In small orifices లో మనము వెలాసిటీని చూసినట్లయితే కాన్స్టెంట్గా ఉంటుంది అనుకుంటాం. బట్ ఇన్ కేస్ ఆఫ్ లార్జ్ ఆరిఫైస్ ద వెలాసిటీ ఈజ్ నాట్ కాన్స్టెంట్. దట్స్ వై దిస్ ఫార్ములా if you use to calculate discharge through a small orifice, you can use Q is equals to CD into A into under root 2gh formula. But in case of large orifice, this formula is not at all applicable because the velocity is not constant here. That's why we go with another formula. So discharge through a large rectangular orifice. How it is done? Derivation part, but derivation is not important. We just remember the formula, that's enough. Let's take this is tank with side of orifice fixed. The orifice is fixed at one side. This is the supply of liquid. Consider a strip in the orifice. Okay, the dimensions are b into dh. The strip is in the depth of dh. Consider a strip, so the area will be b into dh. Then the theoretical velocity will be under root of 2gh. Generally you have q is equals to cd area into velocity. This is the general formula. So this is cd, area of the strip will be b into dh, the velocity will be theoretical velocity under root of 2gh. This is the discharge for elementary strip. If I need the whole element, so I integrate this, I get q as 2/3 of cd into b under root of 2g h to the power of 3 by 2 minus h1 power 3 by 2. This is the formula to calculate the discharge through large rectangular orifice. Remember this formula while calculating, while solving problems. Okay, and next one is discharge through fully submerged orifice. Fully submerged orifice is one which has its whole of outlet side. అవుట్లెట్ సైడ్ అంతా మనకి ఏమవుతుందంటే అవుట్లెట్ సైడ్ అంతా మనకు సబ్మర్జ్ అయిపోతుంది అనమాట లిక్విడ్తో. సో ద డిశ్చార్జ్ ఆఫ్ ద జెట్ ఆఫ్ ద లిక్విడ్ ఇంటు ద లిక్విడ్ ఆఫ్ ద సేమ్ కైండ్, ఇట్ ఈస్ కాల్డ్ యాజ్ ద టోటల్లీ డ్రౌన్డ్ ఆరిఫైస్. టోటల్లీ సబ్మర్జ్డ్ ఏమంటాం, ఫుల్లీ సబ్మర్జ్డ్ ఇంకొక నేమ్ ఏంటంటే టోటల్లీ డ్రౌన్డ్ ఆరిఫైస్ అంటాం. ద థియరిటికల్ వెలాసిటీ విల్ బీ సేమ్ అండర్ రూట్ ఆఫ్ 2gh అండ్ ద ఏరియా ఆఫ్ ద ఆరిఫైస్ విల్ బీ let's see, this is up to the bottom, the height will be h2. From the top of the orifice provided in the side of the tank, it is h1. So the depth we get h2 minus h1, we get the depth of orifice. It multiplied by breadth of orifice, we get the area of the orifice. Discharge general formula is equals to cd times of area into velocity. Substitute area as b into h2 minus h1, velocity as under root of 2gh. This is the formula for discharge through orifice when it is fully submerged. In the next case we see the discharge through partially submerged orifice. This is the figure, partially submerged. Okay, a partially submerged orifice is one which has its outlet side partially submerged under liquid. It is also known as partially drowned orifice. Thus the partially submerged orifice has two portions. The upper portion behaves an orifice discharging free, while the lower portion behaves as submerged orifice. This portion behaves fully submerged. Okay, this is for free. So only a large orifice can behave as a partially submerged orifice. The total discharge q through partially submerged orifice is equals to the discharge through free plus the submerged orifice. Both, this is the submerged one, this is the free. Okay, the discharge through the submerged portion is given by, this is the formula, right, for the submerged. The same formula is applicable here only. Let's say this is submerged case. So at this case h is the upper end, h2 is the lower end. So h2 minus h1 is the height of the orifice for submerged orifice. So into B is the width of the orifice. You multiply with the theoretical velocity under root of 2gh, you get the discharge through submerged portion. And the free portion is given by, it is like a rectangular portion only, flow through a large rectangular orifice only, the formula. So you combined q1 and q2, you get the total discharge. This is the formula to remember. I hope this is clear, this is understandable, and this class is helpful టు లర్న్ ఈజీలీ అండ్ టు గెట్ గుడ్. ఈరోజు క్లాస్లో మనం డిస్కస్ చేసుకునే టాపిక్స్ ఏంటంటే టైమ్ ఆఫ్ ఎంప్టీయింగ్ ఏ రెక్టాంగులర్ ట్యాంక్ త్రూ ఆరిఫైసెస్. ఈ టాపిక్ మనకు వేరియబుల్ హెడ్స్ క్రిందకి వస్తుంది. నెక్స్ట్ వన్ ఈజ్ మౌత్ పీసెస్, డిఫరెంట్ టైప్స్ ఆఫ్ ప్రాబ్లమ్స్. ఫస్ట్ వి సీ టైమ్ ఆఫ్ ఎంప్టీయింగ్ ఏ ట్యాంక్ త్రూ యాన్ ఆరిఫైస్ ఎట్ ఇట్స్ బాటమ్. యాక్చువల్లీ దీనికి డెరివేషన్ ఉంది, డెరివేషన్ మనకి ఏం అవసరం లేదు కాబట్టి ఫార్ములా ఈజ్ సఫిషియంట్ టు సాల్వ్ ద ప్రాబ్లమ్స్. ఇక్కడ ఏం చేస్తామంటే ఫస్ట్ ఒక ట్యాంక్ని కన్సిడర్ చేస్తామన్నమాట. ఆ ట్యాంక్ కన్సిడర్ చేసిన ట్యాంక్కి బాటంలో ఆరిఫైస్ అనేది ఫిక్స్ చేస్తాం. ఓకే, ఈ ట్యాంక్ కన్సిడర్ చేసినప్పుడు దాంట్లో ఉండే లిక్విడ్ యొక్క హైట్ వచ్చేసి ఇనిషియల్ హైట్ ఈజ్ h1. లిక్విడ్ అనేది సమ్ డిశ్చార్జ్ అయిపోతే త్రూ ఆరిఫైస్ ద్వారా సమ్ డిశ్చార్జ్ అవుట్ అయిపోతే లిక్విడ్ అనేది లెట్స్ సే ద హైట్ ఆఫ్ ద లిక్విడ్ ఆఫ్టర్ డిశ్చార్జింగ్ ది లిక్విడ్ ఫ్రమ్ ద ట్యాంక్. డిశ్చార్జ్ అయిపోయిన తర్వాత హైట్ అనేది h2కి వచ్చింది అనుకోండి. అప్పుడు హైట్ h1 నుండి h2కి వచ్చిన టైం ఎంతో మనం ఇక్కడ కనుక్కుంటాం. దాన్ని ఏమంటున్నామంటే మనం టైమ్ ఆఫ్ ఎంప్టీయింగ్ ఏ ట్యాంక్. ఆ h1 నుంచి h2కి వచ్చింది, ఆ లిక్విడ్ అనేది h1 నుంచి h2కి వస్తే టైం ఎంత తీసుకుంటుంది అనే దాన్ని ఇక్కడ మనం కనుక్కుంటాం. దాన్ని ఏమంటున్నామంటే టైమ్ ఆఫ్ ఎంప్టీయింగ్ ఏ ట్యాంక్ అంటున్నాం. దీంట్లో టర్మ్స్ వచ్చేసి ఏంటంటే క్యాపిటల్ ఏ ఈజ్ ద ఏరియా ఆఫ్ ద ట్యాంక్, స్మాల్ ఏ ఈజ్ ద ఏరియా ఆఫ్ ద ఆరిఫైస్, h1 ఈజ్ ద ఇనిషియల్ హైట్ ఆఫ్ ద లిక్విడ్, h2 ఈజ్ ద ఫైనల్ హైట్ ఆఫ్ ద లిక్విడ్, capital T is the time in seconds for the liquid to fall from h1 to h2. that means h1 నుంచి h2కి వచ్చే ఆ లిక్విడ్ లెవెల్ చేరుతుంది కదా, ఎంత టైంలో చేరుతుంది అనే దాన్ని క్యాపిటల్ T అంటాం. CD is the coefficient of discharge. The formula for time of emptying a tank through an orifice at its bottom is given by capital T is equals to 2a times of under root of h1 minus under root of h2 divided by CD times of small a into under root of 2g. This is the formula. ఇప్పుడు h1 హైట్ నుంచి h2 హైట్కి వచ్చేస్తే, ఒకవేళ మనకు ట్యాంక్ అనేది కంప్లీట్గా ఎంటీ అయిపోయింది అనుకోండి, అంటే ఇనిషియల్ హైట్ h1, ఫైనల్ హైట్ వచ్చేసి 0 అయిపోయింది అనుకోండి. దట్ మీన్స్ h2 ఈజ్ ఈక్వల్స్ 0 అయిపోయింది అనుకోండి. అప్పుడు ఈ టర్మ్ అనేది మనకు ఉండదు. అప్పుడు ఏమవుతుందంటే ఈ టర్మ్ తీసేస్తే అదే మనకు ఫార్ములా 2a అండర్ రూట్ ఆఫ్ h1 డివైడెడ్ బై CDA అండర్ రూట్ ఆఫ్ 2g. దిస్ ఈజ్ ద ఫార్ములా ఇఫ్ ద ట్యాంక్ ఈజ్ completely emptied. Then the time of emptying a tank is given by capital T is equals to 2a times of under root of h1 divided by CD under root of 2g. This is the formula for empty tank. This is the formula if the height of the liquid falls from h1 to h2. I hope it is clear. We go for the mouthpiece. What is meant by mouthpiece? First we see the definition of mouthpiece. Mouthpiece is nothing but a short length of a pipe. It is like a short length of a pipe. That length will be 2 to 3 times of the diameter in length. That is the 2 to 3 times of diameter of the mouthpiece. ఈ పైప్ని దేనికి అంటే ఇంతకుముందు మనం ఏం చేసాము, సైడ్లో కానీ బాటంలో కానీ ఆరిఫైస్కి అనేది సమ్ స్మాల్ ఓపెనింగ్ అనేది ప్రొవైడ్ చేసాం కదా. అదేవిధంగా ఇక్కడ ట్యాంక్కి ఏం చేస్తామంటే మనం ఈ పైప్ అనేది ఫిట్ చేస్తామన్నమాట. ఈ పైప్ అనేది బయటకుంటే ఎక్స్టర్నల్ మౌత్ పీస్ అంటాము. లోపల గన్నిందనుకోండి ఇంటర్నల్ మౌత్ పీస్ అని అంటాం. ఓకే, ఈ లెంత్ వచ్చేసి ఎంత ఉంటుందని చూసాం, 2 to 3 times ఆఫ్ డయామీటర్ ఆఫ్ ద మౌత్ పీస్ అని చూసాం. లెట్స్ సే diameter of the mouthpiece is 2 centimeters. Let's say then the length we have to provide is 2 to 3 times of 2, that means 4 to 6 centimeters of length we have to provide. The length of the pipe is provided 4 to 6 centimeters. Okay, ఆరిఫైసెస్ మనం ఎందుకు యూజ్ చేసామంటే డిశ్చార్జ్ కనుక్కునే దానికి యూజ్ చేసాం. అదేవిధంగా మౌత్ పీసెస్ని ఎందుకు యూజ్ చేస్తున్నామంటే ఇట్ ఈస్ ఆల్సో యూజ్డ్ ఫర్ ది మెజరింగ్ ది రేట్ ఆఫ్ ఫ్లో. దట్ మీన్స్ వీ హ్యావ్ టు మెజర్ ది డిశ్చార్జ్ ఓన్లీ, డిశ్చార్జ్ ఆఫ్ ఫ్లూయిడ్ ఫ్లో. డిశ్చార్జ్ కనుక్కునే దానికే మౌత్ పీసెస్ అనేటివి కూడా మనం యూజ్ చేయడం జరుగుతుంది. ద నెక్స్ట్ వన్ ఈజ్ క్లాసిఫికేషన్ ఆఫ్ మౌత్ పీసెస్. ఆరిఫైసెస్లో మనం ఏం చేసాం, సమ్ పారామీటర్స్ని బేస్ చేసుకొని ఆరిఫైసెస్ని క్లాసిఫై చేయడం జరిగింది. ఇక్కడ కూడా సమ్ పారామీటర్స్ని బేస్ చేసుకొని మౌత్ పీసెస్ని కూడా క్లాసిఫై చేయడం జరుగుతుంది. ఫస్ట్ క్లాసిఫికేషన్ ఈజ్ డిపెండింగ్ అపాన్ దేర్ పొజిషన్ విత్ రెస్పెక్ట్ టు ద ట్యాంక్. ట్యాంక్ని బట్టి ఆ మౌత్ పీస్ యొక్క పొజిషన్ని బట్టి మనము క్లాసిఫై చేయడం జరుగుతుంది. ఆర్ వెజల్ టు దే ఆర్ ఫిట్టెడ్, ది సేమ్ మీనింగ్. పొజిషన్ విత్ రెస్పెక్ట్ టు ట్యాంక్ని బట్టి మనం ఏం చేస్తున్నామంటే మౌత్ పీసెస్ని 2 టైప్స్గా క్లాసిఫై చేసాం, ఎక్స్టర్నల్ మౌత్ పీస్ అండ్ ఇంటర్నల్ మౌత్ పీస్. ఓకే, డిపెండింగ్ అపాన్ దేర్ షేప్ we classify the mouthpieces as cylindrical mouthpiece, convergent mouthpiece, divergent mouthpiece. Let's see some figures regarding this classification. If this is a tank, let's say this is a tank. If the mouthpiece is in the external side, it is called as external mouthpiece. If it is inside, it is called as internal mouthpiece. Okay, if the the mouthpiece is in cylindrical shape, it is called as cylindrical mouthpiece. If it is convergent, it is called as convergent mouthpiece. If it is convergent and divergent, that means at this point it is convergent and from that it is diverged. So this is called as convergent divergent mouthpiece. This is called as convergent mouthpiece and this is called as cylindrical mouthpiece. The next classification is based on the nature of the discharge at the outlet of the mouthpiece. Nature of the discharge ని బేస్ చేసుకొని మనం మౌత్ పీసెస్ని ఏ విధంగా క్లాసిఫై చేస్తున్నామంటే మౌత్ పీసెస్ రన్నింగ్ ఫుల్, మౌత్ పీసెస్ రన్నింగ్ ఫ్రీ. ఈ వేటి మీద బేస్ చేసుకొని చేసామంటే మనము ఫర్ ఇంటర్నల్ మౌత్ పీసెస్కే మళ్ళీ ఏం చేసాం, మనం క్లాసిఫికేషన్ చేసాం. మౌత్ పీసెస్ రన్నింగ్ ఫుల్, మౌత్ పీసెస్ రన్నింగ్ ఫ్రీ. ఓకే, వీటిని ఏమంటున్నామంటే బోర్డాస్ ఆర్ రీఎంట్రెంట్ మౌత్ పీసెస్ కూడా అంటామన్నమాట. ఈ విధంగా క్లాసిఫై చేసిన దాన్ని ఎప్పుడు మనం రన్నింగ్ ఫ్రీ అంటాం. ఏ మౌత్ పీస్ ఈజ్ కాల్డ్ రన్నింగ్ ఫ్రీ ఎప్పుడు అంటామంటే జెట్ ఆఫ్ లిక్విడ్ ఆఫ్టర్ కాంట్రాక్షన్ డస్ నాట్ టచ్ ద సైడ్స్ ఆఫ్ ద మౌత్ పీస్. దట్ మీన్స్ దిస్ ఈజ్ ద మౌత్ పీస్, లెట్స్ సే దిస్ ఈజ్ ద మౌత్ పీస్, ద జెట్ ఈజ్ నాట్ టచ్ ద సైడ్స్ ఆఫ్ ద మౌత్ పీస్. ఆ సైడ్స్కి గాన జెట్ ఆఫ్ ద లిక్విడ్ అనేది గాన టచ్ కాకపోతే దాన్ని ఏమంటున్నాం, మనం రన్నింగ్ ఫ్రీ అంటున్నాం. అదే మౌత్ పీస్కి వాటర్ అనేది అంటే ఆ లిక్విడ్ అనేది ఆ సైడ్స్కి తగులుతా పోతుందనుకోండి, ఎక్స్పాండ్స్ అయిపోతుంది అనుకోండి, అప్పుడు ఏమంటామంటే రన్నింగ్ ఫుల్ అంటామన్నమాట. ఓకే, రన్నింగ్ ఫ్రీ అంటే ఏంటో, రన్నింగ్ ఫుల్ అంటే ఏంటో తెలుసుకున్నాం కదా. నెక్స్ట్ వన్ ఈజ్ నెక్స్ట్ ఏంటంటే సమ్ ప్రాబ్లమ్స్ అని చూసాం కదా సిలబస్లో. కాబట్టి కొన్ని టైప్స్ని చూద్దాం ఇక్కడ. వాటికి సంబంధించిన హైడ్రాలిక్ కోఎఫిషియంట్ వాల్యూస్ ఏ విధంగా చేంజ్ అవుతున్నాయి ఇది చూద్దాం. ఇవే అడుగుతున్నారు ప్రీవియస్ ఇయర్ క్వశ్చన్స్లో కూడా. కాబట్టి ఇవి నేర్చుకుంటే చాలు, సరిపోతుంది. ఫస్ట్, ఫ్లో త్రూ యాన్ ఎక్స్టర్నల్ సిలిండ్రికల్ మౌత్ పీస్. ఎక్స్టర్నల్ సిలిండ్రికల్ మౌత్ పీస్ అంటే చూసాం కదా, ఇదో సిలిండ్రికల్ మౌత్ పీస్ ఈజ్ ఎట్ ఎక్స్టర్నల్ సైడ్. ఇట్ ఈస్ కాల్డ్ యాజ్ ఎక్స్టర్నల్ సిలిండ్రికల్ మౌత్ పీస్. దీనికి కోఎఫిషియంట్ ఆఫ్ కాంట్రాక్షన్ వచ్చేసి 1 ఉంటుంది, అండ్ కోఎఫిషియంట్ ఆఫ్ వెలాసిటీ విల్ బి 0.55, and coefficient of discharge will be 0.55. Why? CD is equals to CC into CV. So CV is equals to 0.855 and CC will be 1. So 1 into 0.855, then the CD value will be 0.855 only. Okay. Next, the flow through mouthpiece general formula is CDA under root of 2GH. This is the formula to calculate the flow rate through the mouthpiece. But for the external cylindrical mouthpiece, the CD value will be 0.855, right? So we substitute the value, we get the flow through mouthpiece for an external cylindrical mouthpiece is 0.855 times of A into under root of 2GH is the formula. Okay, we observe the CD values. Observe the CD value for mouthpiece and for orifice. For the orifice, the CD value will be 0.62. For this case, the CD value will be 0.855. So we give a point that the value of CD for mouthpieces is more than the value of CD for orifices. That's why the discharge for the mouthpieces is more when compared to the orifices. Discharge through mouthpieces is greater than discharge through orifices. Why? Because the CD value is more in case of mouthpieces when compared to the orifices. This is the reason. Next, we give a formula. This note point is to remember this also. Why? Because they ask a question in this formula also. This is external mouthpiece, right? This is a section 1:1. This is a CC. That means it is vena contracta. The absolute pressure head at vena contracta we can measure. The formula is given by HC is equals to HA minus 0.89 H. H is this. HA is atmosphere and HC is this. At vena contracta, the height, the pressure head, let's say the pressure head at vena contracta. HA is the atmospheric pressure head. In terms of water, we give it as HA is equals to 10.33 meters of water. This is a value. We discuss this value in sorry, it is 0.3 meters only, 10.3 meters. We see this value in pressures topic. ఎవరైనా ప్రెషర్ టాపిక్స్ చూడనట్లయితే లింక్ డిస్క్రిప్షన్లో ఉంటుంది, వెళ్ళి చూడండి. దిస్ ఈజ్ ద ఫార్ములా టు క్యాల్కులేట్ ద అబ్సల్యూట్ ప్రెషర్ హెడ్ ఎట్ వేనా కాంట్రాక్టా. వాట్ ఈస్ ద ఫార్ములా? హెచ్సి ఈజ్ ఈక్వల్స్ టు హెచ్ఏ మైనస్ 0.89 టైమ్స్ ఆఫ్ హెచ్. హెచ్ ఈజ్ ద head of the liquid. HA is the atmospheric pressure head. HC is the atmospheric pressure head at vena contracta. Okay. The next one is flow through a convergent divergent mouthpiece. Convergent divergent ki or convergent mouthpiece ki both have the coefficient of discharge will be 1 only. CD value for a convergent divergent mouthpiece or a convergent mouthpiece both have 1 CD value. Flow through mouthpiece formula is Q is equals to CDA under root of 2GH, right? The CD value will be 1, so the formula will be A into under root of 2GH. This is the formula for flow through mouthpiece for a convergent divergent mouthpiece. There is a ratio, area ratio formula. There is a area ratio formula for section 1 and for section CC. That means section CC is at vena contracta, and at 1 is at the atmosphere, the free discharging at the end last anamata. So at 1 by AC, the formula 1 plus HA minus HC by H, it is under root. This is the formula. Why VC by VA? V1, A is inversely proportional to V, right? So A1 by AC is equals to VC by V1. So both have the same formula, under root of 1 plus HA minus HC divided by H is the formula for the area ratio and velocity ratios for section 1 and at vena contracta. Okay, the next one is flow through an internal mouthpiece. We see the mouthpiece is at inside of the tank. This is, in this case we have two cases, a running free case and running full case. This is also called as Boda's mouthpiece. In the previous slide I told you Boda's mouthpiece or re-entrant mouthpiece. We call it as Boda's mouthpiece or re-entrant mouthpiece. The coefficient of contraction will be 0.5 for this case, and coefficient of velocity will be 1, coefficient of discharge will be 0.5. Flow through mouthpieces CDA under root of 2GH, CD value is 0.5, then the formula is written as 0.5 times of A into under root of 2GH is the flow through mouthpiece for an internal mouthpiece. This is the formula. So the next one is Boda's mouthpiece running full. In the last case we see it is running free, that means the liquid does not touch the walls of the mouthpiece. But in this case the liquid is touches the walls of the mouthpiece. In this case the coefficient of contraction will be 1, the coefficient of velocity will be 0.707, coefficient of discharge will be 0.707. The flow through mouthpiece will be the general formula CDA under root of 2GH. The CD value is 0.707, then the formula is written as 0.707 into A into under root of 2GH. Up to this, the flow through orifices and mouthpieces chapter is over. In the next class, we see the previous year questions and some expected questions. I hope this class is helpful to learn the subject very well. In the next class, we see the previous year questions. Thank you.